mám sledovat stream?
Tady jsem ti do zprávy posílal GeoGebru.
In a world where space and time are intertwined, one man dared to challenge the status quo. His name, Dayton Miller. His weapon of choice, a flute, but not just any flute.
Držák vám musím skočit zpátky. Ano, ruším. Tak.
Že máme ještě zhruba 10 minut, než to odehraje, jo.
Jasný, to je.
We still have like 10 minutes till the songs are finished.
You guys rock 10-minute intros? That's respect.
Já ještě jednou zkusím to praštění.
Yeah, we like our songs, guys.
Yeah, technical difficulties or something
Jirko,
too.
já když kliknu na přímé zprávy a na tebe, tak mi to tam jenom ukazuje, že streamuješ a já vidím ten tvůj stream.
Kde tam klikáš?
Ale není tam vůbec... už se mi to tady objevilo.
Tak.
Takže co mám dělat? Fajn. Počkej, takže...
Tak, hele, ještě jeden pokus. Jardo.
Zpátky.
Máš ještě čas, zkoušej, já už vysílám.
Ty musíš říct, jestli to vidíš nebo nevidíš, já to nepoznám.
Nevidím. Já bych zařval, kdybych to viděl.
No. Hele, je to hodina, co všechno běželo.
Jarda podle mě je vidět, ty ne.
Jo, výborně, tak to stačí, Jarda ukazuje to též. Tak, Jardo, já si tě samozřejmě navedu, jo?
No, chtěl jsem říct, protože vím, no.
Úplně v pohodě, já si tě zvětším. Moment.
Míšáku, běží písničky?
Ještě vydrž, Jardo, prosím.
YouTube jede. YouTube OK.
YouTube OK, ale já ti pošlu ještě jiný odkaz, Jardo.
Ne?
Jarouškovi.
Hlásím, že u Mrvíka to běží.
To je to nejdůležitější samozřejmě. Ať si to kluci užijou. My budou slavit naše technické problémy, pochopitelně, že jo. Tak. Jaroušku, ty dostaneš nový odkaz teďko ode mě, jo? Teď už ho máš nacvičený, že jo? Tak. Kde já tě mám, Jaroušku? Tady na tebe koukám. Takže zpráva. Vypadá velmi podobně ten odkaz, ale je to na aktuální verzi, jo? Je tam, kde byl ten první. Tak. Výborně. Klikni prosím tě nahoře na to FE, vlevo nahoře, jo? Super, děkuji. A klikni na triangles, na trojúhelníky jednou. Ještě jednou. Paráda. Yes. A i to u tebe hezky vypadá a je to vzorný. Paráda. Děkuju.
V pohodě.
Tak a já budu muset koukat na Jardovo obrazovku, že jo, Jardo, abych viděl časobota, je to tak?
Jo, to tam dám potom, jo. Teďko jenom koukám, abyste viděli tohleto, když začne. Já si beru slovo hned na začátku, všechny přivítám, Martin to přeloží do angličtiny a pak se domluvíme, protože kluci byli proto, aby maximální čas jedné relace byl 3 minuty, což já jsem taky za.
Hovorili 2 minuty, ale že im to je v zásade jedno.
Jo, OK.
3 minuty jsou v pohodě, já s tím nemám problém. My jsme to prostě posouvali kvůli ní ve skutečnosti.
Máme čas do začiatku?
Ještě spoustu.
Ještě máme 5 minut zhruba. No. Jedna písnička, nebo jedna upoutávka a hymna jedeme, jo?
So we still have like 5 minutes, guys.
Okay. I'm going
Because
to
we love
order.
the songs.
Yeah.
I am going to order coffee. One last coffee today.
Yeah, actually I'm going to grab coffee too. I'll be back in few. Som hovoril, že tiež si idem spraviť kávu, hned som späť.
OK.
Lásko.
Okay, 1 minute this clip, and 3 minutes Space Leakos Justice song. Sorry.
Yeah, so coffee ordered, guys. I'm with you again. No, Jaroušku, ty budeš muset přepínat mezi těma streamama, viď?
No, asi se z toho opupínkuju, ale tak nějak to dáme dohromady.
No, ty streamuješ celou obrazovku, předpokládám.
Já mám celou obrazovku.
No, takže vždycky, když domluvíš,
Já
tak se přehodíš. No.
Jo, možná, kdybych se uklikl, tak...
Ale v podstatě postup je jednoduchý. První kliknutí je to FE nahoře, pak to je to vedle to prostřední, to divný FE, jo. A v divném FE se potom ukazuje vždycky, když na to klikneš, jo, první se zmáčkne Calculate, to spočítá pozice, to můžeme ukázat a nemusíme, pak se vlastně začne u FE u plochý země a důležitý je, že v podstatě vždycky to můžeš vyškálovat, to je to skale, to se dá zvětšit až na 20, kdy to jakože vytáhne, nebo se to dá normálně naskrolovat myšítkem a pak to zůstává v reálných úhlech. Další je to ta divná plochá země, kde ji naškáluješ na 20 a potom vlastně popotáhneš ten parametr K úplně na 1 doprava, ten to zakřivuje.
Ježíš, hele, zahlcuješ mě, budeš mě muset studovat
budu postupně řešit a postupně radit.
Mám limitovaný mozek.
Tak, paráda.
Som späť.
Já už taky.
Slunce přece není hvězda od světla v domnělé pozici. Odkud bere šťávu, něco se mi nezdá, asi je to koule zářící. Jen sokolí nevidí. A to dáli se díváš, tak se do jednoho bodu spíjají. Je to jenom celou pouhá perspektiva, fyzicky nejsou tam, kde by měli být. Ale já na to kašlu, to se nedá. Ty koleje tam jsou vidět, ale fyzicky tam nejsou, protože domnělá pozice. Proč? Jak je tohle možné? Všichni jim lžou a tak jedou dál. Faktů přehlížení je jich děsí.
Utlo to zvuk?
Jo, to vypíná Jarda vždycky, než to přeskočí na živý stream, takže bacha, teď každou chvíli už budeme živě.
Okay, we will be starting in a few seconds. You can turn on your cameras if you want. 10 seconds.
5 seconds.
4, 3, 2, 1. Let's go.
Tak, krásný večer všem. Dneska nás čeká debata, která je přímo přes moře, transatlantická debata. Vítáme Shayna, vítáme Alana a za nás se zúčastní Jirka a Jarou Spolame. Ahoj. Hi.
Hi guys, welcome. This is our first transatlantic debate with you, so welcome here and feel free, feel like home in here.
Thank you for having us.
Thank you guys. Good to meet you. Hopefully we can have a good time.
Já taky všechny zdravím při večeru, všechny jsem rád i za to. So, hi guys, thank to having you here and good evening or afternoon for your viewers too.
No
You
a já
as
teda
well.
taky pozdravím. Dobrý den, dámy a pánové, tady Jarda. And good evening, ladies and gentlemen. So enjoy our today's debate.
Super, takže všichni jsme se pozdravili. Téma je dneska nebeský teodolit a všechny jeho aspekty. Martine, prosím.
The theme for this evening is the jak se to povie, celestial theodolit and all of his aspects. Its aspects.
OK, takže já bych měl moderovat, ale moderovat bude je to, kluci uviděj, tenhle ten tmavý čtverec tady, co vy vidíte vpravo dole, a ten bude řídit celou debatu. Je to náš časorobot a ten to bude řídit.
So all of us, we will see the bot timer in Yarda's screen and it will be our moderator today.
Trust in the bot, they say. Okay. They told us right before they took over. Just kidding.
Yeah, that is Skynet. It's the beginning.
Started as a timer. Went all downhill from there.
Okay. This is my share screen on the Discord is full screen. OK. Jo, já budu mluvit česky asi. Martine, prosím tě, teďko v této chvilku kluci se domluvili, že jedna relace, to znamená, jak dlouho můžou mluvit, bude 3 minuty a celková doba bude u každého účastníka 30 minut. Je to tak?
Ano. Okay, so as we discussed before, the rounds will be 3 minutes each and the total it will be 30 minutes each per person. So we will set the bot for 3 minutes and, so on, so on.
Cool.
Nastavuji.
Whenever you're ready, let me know.
Kedykoľvek môžeme začať. OK, takže ešte by si mal povedať speakery, po porade speakerov, dajme tomu.
Jasný, takže první diskutér Jirka Vacek, druhý diskutér Alan, třetí diskutér Jarda Polame a čtvrtý diskutér Shane St. Pierre.
Okay, so first is Jarda, second is Alan, third is Mr. Polame, and the fourth is Shane.
Copy.
OK, můžeme startovat?
Za mě
Can we
ano.
start?
I'm ready.
Are you ready,
Ready
guys?
to go.
Yeah, probably. Yeah.
To pojechali,
Okay,
rybята,
we can start.
pojechali.
OK, so start.
Já jsem na řadě první zjevně. Dobrá, takže my jsme se sešli dneska výhradně kvůli nebeskému teodolitu, a to i z toho důvodu, že jsme ho řešili mnohokrát na české scéně a v podstatě na naše základní dotazy jsme se nedobrali odpovědí. Ty základní dotazy jsou jednoduché, ale já bych rád začal nějakou definicí toho, co my si vlastně pod tím pojmem nulová hypotéza nebeský teodolit z naší strany představujeme. My si představujeme, že touto metodou kluci srovnávají konkrétní jev na modelu ploché a kulaté země. A za mě je důležité si říci, čím se ty dva modely liší. Za mě je důležité si říci, že
rovina... Ja ti do toho skočím ako translator, že už toto je docela na mňa dosť. Na prekladanie. Je ma počuť? Je vlastne... pardon.
Jo, OK, ty jsi to hodil zase zpátky na mě, tak tady došlo k minule. I tried English. OK. As first, I think we have to make some common definitions between us and you guys. So, because in my eyes, self-view is your method how to solve the problem about Earth shape. And so, through comparison between flat Earth model and globe Earth model. So we have to define which is common for both models and which is not common. And from my point of view, we have horizontal plane on Pikes Peak, so to say, on mountain peak, on top of the peak, and it's horizontal plane. And we have horizontal plane on the observer position, so some water level on both places. And in your case, are those planes parallel? In our case, are those planes not parallel? And that same is valid also for vertical lines through peak and through observer position. In your case, are those vertical lines parallel together? In our case, on globe Earth, they are not parallel. And by the same moment, it is correct to say that the vertical line on the peak or on the observer positions is perpendicular to his horizontal plane, but not to the other plane in our case. So it's yours, Martin, for our Czech viewer.
Jo, pardon, bol som teraz zahltený tým. Prakticky sa snažíme nájsť spoločnú reč medzi tým nebeským teodolitom, tak ako to chápu oni a my. Pretože vychádzajú rôzne výsledky medzi nimi, že nejaké paralelné linky vychádzajú na plochej zemi, nejaké nevychádzajú. Pokiaľ som to správne pochopil. Ja myslím, že budem potrebovať kratšie intervaly na ten preklad.
Alan now.
Yeah.
Oh, sorry. I thought he was doing this whole intro. Okay, I got you. Okay, can I screen share?
Alan chce screen sharovať.
Let me know when you can see the screen.
Yes, we can see the screen.
In regards to the globe saying, or them saying that the lines wouldn't be parallel and that the analysis is flawed because it would be parallel on a flat Earth versus not a globe, we actually subtract the angular difference from the drop from drop over distance from the mountain peak. So the triangle that we construct would be congruent based off of the occlusion time, and it would verify the globe. So like we're forcing congruency in there, but it's based off of subtracting the amount of drop as an angle from the flat Earth prediction there. And we know that that's correct and accurate because we can use central angle theorem to verify it. So central angle theorem and how it relates to the ground and the stars is there's 90 degrees of celestial motion per 45 degrees of terrestrial motion that we perceive. So in other words, the drop over distance between the peak and the observer is always half of the full celestial motion, which we verify through two equations, which I can show you on the spreadsheet, which are 360 times the distance over 2 pi r, and then we'd use 180 to get the half of that is the drop over distance. So what you can do to verify that this is correct is you could take the true elevation at the peak and you could take the true elevation for the observer. You could subtract those two and it comes out to be 45, which is what we get here for the celestial drop, and half of that 45 comes out to be 13.5. So that's, it's literally half of that. So everything we're doing is completely viable, and it's exactly it's all trigonometrically viable. So the concern about the parallel lines is misplaced.
Ach jo. Hele, neviem.
So
Takže prakticky...
Sorry, oh, go ahead.
Hovoril niečo o nepochopení
Do you need me?
Ale toto asi nedám. Omlouvám se.
To bylo moc dlouhý. Příště to udělej kratší a zastav si je ty, Marťas, jo? Prosím tě. Sorry, omlouvám se.
Okay, we will need to do a shorter debate probably, because I cannot translate all the things you said.
Okay. Let me take a second crack at it. I can speak shorter. We'll try that. So in regards to the concerns about the parallel lines versus flat Earth and globe,
že čo sa týka nepochopenia paralelných liniek medzi plochou Zemou a globom,
we apply central angle theorem over the distance to get the drop as an angle.
Aplikujeme centrálnu uhlovú teóriu na vzdialenosť, aby sme z toho dostali uhol.
We can subtract that angular amount from the physical elevation of the mountain.
Moment. Vstoupím do toho jako moderátor. Řekni prosím tě všem, jestliže budeš překládat po větách, tak ať zůstanou odmutovaný u sebe, ať nejsou šediví. Ty si je zastavíš sám. A jim se zastaví čas, pak můžou pokračovat automaticky, když ty se zamutuješ.
Okay, when I'll be translating after a few sentences. You don't need to mute yourself. I will be doing that for you.
I can. Well, I was pausing to let you translate this sentence because it's only going to get more complex from here. So I can do a couple sentences at a time for if it helps you. That's what I was doing. So, and I'm used to muting myself anyway. So.
Yeah, thanks. But when I turn on my mic, it will pause you out automatically, I think.
Sure. But how do I know that you're like, here's the thing. If I just start talking and then you don't get the whole thing or enough of it, we don't know where to go back to. So if I do it in segmented sections and you just translate the sentences as we go, I think that would be a lot easier. Like if I do
for
a couple,
me, definitely.
Yeah, for sure. Let's just do that. It's the easiest way.
Okay.
All right. Cool.
Já jsem taky pro, kluci jsou úplně v pohodě, já si myslím, že se zvládnem střídat i bez toho.
Takže ja to iba preložím z toho, že som neschopný a nestíham to proste celú túto odbornú debatu prekladať, tak to budeme segmentovať, aby som to stíhal.
Dobře.
I think you can continue, Alan.
Gotcha. Okay. So let's see where we were. Did you translate the part about the central angle and all that?
Yes, I tried to my best knowledge.
Okay, cool. So by subtracting that difference from the physical elevation, we establish a separate triangle prediction for the globe.
Takže tým, že sme odčítali rozdiel od psychickej výšky, môžeme určiť separátnu trianguláciu alebo predikciu triangulácie na globe alebo pre globe.
And that triangle would produce congruent angles because it's just based off of the occlusion timing. Congruent just means it would produce the same angle on the other side of the triangle.
Oh, right, thanks. Že ten istý uhol by bol rovnaký na opačnej strane toho trojuholníka.
So the concern about parallel lines on a flat Earth for the observer to the peak versus non-parallel lines for the globe isn't a valid concern.
Takže obava toho, že paralelné linky na plochej Zemi k pozorovateľovi versus paralelné linky na globe nie sú validný argument.
We can verify the correctness of what we're doing by subtracting the difference from the true position at the peak from the true position at the observer location.
Môžeme overiť pravdivosť tvrdenia toho, čo robíme, odčítaním rozdielov medzi pravou pozíciou na vrchole od pravej pozície pozorovateľa.
So in other words, in order for that star to traverse 50,000 meters on the terrestrial sphere.
Takže inak povedané,
in order for the star to traverse 50,000 kilometers over the ground.
Takže inak povedané, pre hviezdu, ktorá cestuje 50,000 kilometrov nad Zemou.
On tím myslel délku trasy, kterou urazí. Do you thought the path of the star in this distance, 50,000 kilometers on the sky over the flat Earth. Understood?
Yeah, I misspoke.
Right.
It's 50 kilometers, I meant to say. For it to traverse 50 kilometers over the ground, there has to be a full 90 degrees of celestial motion. So that number that we got from subtracting these two comes out to be 45, which is what this number is from the 360 times the distance, and half of that is the drop over distance. So in other words, everything we're doing is mathematically correct and verified by the star's position from Stellarium.
Jarušku, asi ty? Si na řadě?
No, ja to by som to ešte preložil teda. Hovoril, že sa pomýlil, je to 50 kilometrov a myslel tým, že pokiaľ hviezda prejde 50 kilometrov nad zemou, tak plných 90, tak spraví plných 90 stupňov nebeckého pohybu. Takže číslo, ktoré sme dostali odčítaním od týchto dvoch, už malo by byť 45 stupňov.
Ono je to trošičku... Tam se vychází z toho, že 1 stupeň nebeského pohybu je 60 námořních mil, takže těch 50 kilometrů, který ta hvězda urazila nad zemí za tu dobu, jakoby, tak by mělo odpovídat tomu polovičnímu úhlu, kterým oni nahrazujou ten rozdíl těch našich nerovnoběžných a rovnoběžných tížnic. I have a little bit helped with translation. Nothing more at this moment.
Jo, ďakujem, pretože toto ide trochu mimo mňa. OK, we can continue.
Okay, so whose turn is it?
Koho je teraz?
It's your or Jarda Polame turn, Alan.
Oh.
I'm after Shane again.
So okay, it's my turn now. Tak já to zkusím napřed česky, takže budu to číst po větách, takže když tak mě zaráž, ať to můžeme přeložit. Takže ještě jednou dobrý den, dámy a pánové. Já jsem Jarda z Brna a znovu vás tady s Jirkou vítáme u této debaty. Ano, je rok 2025 a my tady teď bohužel řešíme, zda je Země plochá či kulatá. Zástupci ploché Země totiž přišli s údajně obrovským objevem, a to takzvaným hvězdným teodolitem. Martin, budeš to překládat, nebo?
Jo. Okay. We are welcoming you here again, and it's 2025, and you guys came up with the celestial theodolit again, which is supposed to prove the flat Earth. Můžeš pokračovat.
Tato metoda začala poměrně slibně, a to opravdovým měřením úhlů pomocí klasického teodolitu. Bohužel už tehdy jsme dokázali, že tvrzení vyplývající z tohoto měření nemohla být pravdivá.
This method started fine. Ešte raz, prosím ťa, musíš kratšie veci, prepáč.
A opravdovým měřením toho úhlu, jo, že opravdu fyzicky měřili ten úhel mezi pozorovatelem a tou horou.
Okay, it started correct that you started to measure the angle between the peak and the observer.
Ale už tehdy jsme dokázali, že prostě to tvrzení není pravdivé.
But we already debunked it at the beginning.
No,
můžeš.
A teda v následujících updatech, kterých je teda mimochodem za poslední rok tuším 23, 20.
So after that you made some updates to the celestial theodolite, which is like 23 for the last year.
Se od těch ověřitelných měření úplně upustilo.
You abandoned the ověřitelné měření.
Verifiable.
Řekni,
You abandoned the verifiable measurement.
Can you clarify that? That sounds important. Can you clarify that?
Že či to môžeš vysvetliť, znie to dôležito.
What?
To, že opustili ověřitelné měření.
Or what should I?
Ne, že opustili to overiteľné meranie.
There was only one measurement by the real physical theodolite, and this was the first one from Heffron's place to the Pikes Peak. There was no other angle measurements.
Bolo
Am I
iba
right,
jedno. Vlastne,
Gotcha. So is that it? Or was there more?
No. I have it much more, but I'm thinking how to do it right now. If I continue in English or continue in Czech. So I try in Czech. I try to continue in Czech, and if it will be too long, so I'll make it short. Martine, takže jo, zkusme to ještě. Nikdo a nikdy nedokáže jakékoliv tvrzení a závěry vyplývající z této metody zpětně ověřit, protože jsou neopakovatelné.
No one can verify the measurements because you cannot repeat it.
A můj názor je tedy takový, že tento objev, stejně jako cokoliv předtím, nefunguje, což jsem připraven dokázat.
And my opinion is that this is not working, the celestial theodolite, which I'm prepared to prove to you.
OK, continue. Používáte špatné vstupy a předpoklady, takže i výstupy musí být logicky špatně.
You are using wrong inputs. That means the outputs are incorrect too.
Generally, shits in, shits out.
Wrong premises, not inputs. Wrong premises, Martin.
And inputs as well. Když jsem tuhle metodu použil přesně podle vašeho návodu,
when I used your method exactly,
according to your operational manual.
Yeah, according to your propositions. Tak jsem zjistil, že buď nedokazuje vůbec nic.
Well, when I used your method exactly as you prepared the manual for it or something, I didn't find anything.
So it doesn't prove anything at all? Nebo dokonce vyvrací sama sebe?
So it, yeah.
Or it
So it doesn't prove. So basically, your method is disproving yourselves.
In some cases, of course. Jedním z klíčových bodů je, že pro závěry používají špatný model.
One of the key points of the method is that you are using the wrong model.
I mean a globe. Takže i predikce pro kulatou zemi tím pádem.
Basically, you are using globe as a model.
You are using wrong globe Earth model, and so far even your predictions for the globe Earth, and that means that even the results are logically wrong. Takže ještě pokračujeme dál. No a dokud se tohleto teda neopraví tak, aby používali správný model, je celá metoda špatně nejen z faktického, ale tedy i formálního hlediska.
So if you not correct the wrong model, that the whole method is incorrect from logical point of view.
Even formal.
Or
Yeah, I got it.
OK. Taky nechápu, proč jako vstupy se používají data získaná z modelu kulaté země.
I don't understand why you using inputs from the globe Earth.
Stejně jako další vybavení, které vychází z klasické vědy.
And all the... Nevím, čo ty myslíš, prepáč.
And all other resources or equipment based on classic science. Why don't you use your own flat Earth model or equipment or resources? Tak a poslední odstaveček. Metoda měla změnit celý svět. Bohužel už skoro rok čekáme a pořád nic a nic.
And the last part is that your method should change the whole world, but we are waiting last year and nothing's happening.
Yeah, and that's all from my side for now.
Okay, it's my turn.
So, your turn, Shane.
Can I screen share real quick?
I think you can.
We see nothing.
No? How about now?
Oh, yes. Sorry.
I see it.
All right. So, real simply, I'm going to start off with the basics, if that's okay. We're going to make a deduction based on a simple observation.
Okay. Takže začneme jednoducho. I'm hearing echoes from someone.
Yeah, okay, I thought that would happen. Hold on.
From Shane, sorry.
I gotta switch to actual Discord. 1 sec.
Ugh, disgusting.
Prakticky hovoril, že začneme jednoducho, začneme od základov, pokiaľ je to OK. Vyskúšame dedukciu založenú na základných alebo jednoduchých pozorovaniach.
Go on. So we see your screen sharing with your message. Your voice has been disconnected. Shane. So maybe you say something, but we hear nothing.
Shane, we cannot hear you. We see your stream or sharing screen, but yeah.
Yo, now's an excellent opportunity to say, is this a Windows problem, Shane?
By me was that not Windows problem. I'm on Linux, but something what.
Yeah, he's always busting my chops for having Linux issues.
So, but it is for sure very interesting experiment, but I hear really know one word. Určitě je to velice zajímavý experiment, ale já fakt neslyším ani slovo od Shane.
Alan, can you check on Shane?
I'm here.
Yeah,
he's
Yep.
okay.
Yep. There we go. Oh, I had you turned in. There you go.
Yeah, my program's been all right. So no audio. Now we should be good. No echo.
Yes, we can hear you.
Okay, so no echo, and we can hear and we can see.
Yes, sir.
Okay. All right. So like I said, we're going to start with a simple observation and then a series of deductions or a deduction from there. And we're going to compare flat and globe models.
Takže ako hovoril, začneme jednoduchými pozorovaniami, zo pár dedukcií a odtiaľ prejdeme na porovnanie plochej, modelov plochej a globálnej Zeme.
So we're going to use very basic parameters. This is the observation in question playing in the background, a star going behind a mountain peak.
Takže začneme s základnými parametrami. Toto je pozorovanie, o ktorom sa bavíme, a je to hviezda, ktorá zapadá za vrch hory.
Okay. Now, with that observation, we have a little bit of information. We have the height of that peak, the height of us above sea level, and our distance from that peak.
Takže máme nejaké základné informácie, máme výšku vrchu, máme našu výšku nad morom a vzdialenosť od kopca.
Using just that basic information, we're going to construct a comparison to compare the geometric globe and a flat Earth.
Na základe týchto informácií si môžeme skonštruovať porovnanie alebo porovnanie vlastne geometrického modelu Zeme a plochej Zeme.
So again, using just that basic observation, we're going to construct a triangle and we're going to calculate arctangent of the rise over the run.
Že na základe toho pozorovania si môžeme skonštruovať trojuholník, cez ktorý môžeme vypočítať arctangent vzorec.
One question, Shane. Rise is distance 50.7 and rise is difference between heights of Pikes Peak and heights of Observer.
Delta height.
Yeah, thank you. Got it. Got you.
So then we can, like I said, we can calculate that and that'll give us a answer in degrees. And then that degree will correspond to a time.
Takže na základe toho pozorovania získame nejaký uhol, ktorý potom korešponduje s časom.
Okay, got you.
And then
globe?
We can do the same for the globe. We would construct a smaller triangle because of the geometric difference between flat and Earth over this distance.
Mm-hmm.
Že na základe toho môžeme spraviť rovnakú vec pre Zemegulu, gulatú.
For 50.7 kilometers, that's 201 meters. And here's 7 different ways to calculate the geometric drop and the drop over distance on a globe. And here's 7 different answers. There's 7 different formulas coming up with the same 201 meter difference.
Okay, got you.
Okay, now
Na základe...
go ahead.
Môžeme použiť 7 rôznych vzorcov na výpočet a neviem, dostal z toho 201 metrov. Možno by chalani ste vy chceli vysvetliť.
Tam se to liší o setiny milimetru.
So the only difference between our two predictions now is going to center around this 201 meters. This is going to be the crux of the difference of the comparison.
Takže jediný rozdiel medzi týmito dvoma predikciami je centrálne niečo, s tými 201 metrami.
Because if we do the same, a smaller triangle and incorporate that 201, 202 meter difference, we get a different angle. It means a different time.
Yeah.
The only difference is this 202 meters, okay? So then what we have then is a mutually exclusive comparison for a single observation. We have two competing angles at which we predict that star would be occluded by that mountain.
Takže ako som to správne pochopil... Čože?
Ja, povídej, promiň.
Že ak som to správne pochopil, tak rozdiel medzi plochou a gulatou zemou je tých 202 metrov.
201 až 203 metrů podle toho, který výpočet použiješ, to není až tak podstatný. V tom fakt není problém nebeského teodolitu. So, no, go on.
Right, so
or our turn.
So one last piece. The only other piece of the observation is the time of the observation, which we now have a concrete comparison point when that mountain peak occluded that star. And then we use that time to compare which model is correct.
Takže jediný ďalší kus evidencie alebo pozorovania je vlastne ten čas, ktorý môžeme použiť na to, že ktorý z tých modelov je správny.
And in this example, we find out that actually the star was occluded at 2:32, so our prediction was much closer than the 2:17 prediction for the globe. And that means that that 202 meters is the reason that it's different, and that's the amount that it's off. So the absence of Earth curve evidenced by this single observation.
Takže v tomto prípade vieme, alebo sme našli, že hviezda, ktorá je súčasťou tej chyby 232, je na našom modeli bližšie k tej predikcii ako na globe. To znamená, že...
Já na to pak budu reagovat komplet.
Okay.
One final point. Sorry, you said there was only a single observation. There's many observations. There's 8 different peaks. There's about 52 different observation points that all congruently have the same conclusion. So we'll go into that if you want later. And that's it.
OK. Jaroušku, hoď tam prosím tě to sdílení moje, jo, tu GeoGebru, a prdni mi tam ten prostřední odkaz horní. So, Jarouš will screen share for me this one. It is principally your Celestial, as you say. It is modeled here for home of Dr. Heffron and for Pikes Peak. Pikes Peak is on the left, the home of Dr. Heffron is on the right. Járo, klikni prosím tě na to Weird FE nahoře, because that was my question about those parallel and unparallel lines. Because, Shane, you have in your globe model, and I say your globe model, because it is not our globe model. Our globe model works in other way. I'm sorry. Way other way, so to say. Járo, prosím tě, skale na 20, we can scale it up to 20, so for better view. So in scale 1, we have correct angles there as in your model, Shane. And if I understood you right, your difference between flat Earth model, which is the big red triangle in the middle, and globe Earth is a subtraction of this half angle. This is the blue line piece under Pike's Peak top. If I understand you right, correct?
Did you get it?
Right. So the half angle, you're converting the 202 meter difference to an angle.
So because you are counting with Arcus tangents, and we both know Arcus tangents works only and without any exception only in right angle triangle. Sure?
To be honest, we can't see what you're showing at all. It looks interesting, but it's very blurry.
No.
You see it. Can you see it, Alan?
It's blurry, but he's just basically reiterating the same argument that the triangle is invalid. You didn't get what you said at all about two different triangles and comparing them by subtracting the angular difference from the elevation of the first one for mutually exclusive outcomes based off of timing. You didn't get it at all. You're going to have to redo it. Anyway,
okay.
Anyway, proceed on, sir.
Rozumel si tomu?
So have I understood your modeling of globe correct?
No, you've completely bastardized it, and then did something else.
No. You count with Arcus tangents of rise and run, correct? In both models.
Yeah. Did you hear the part though about how we subtract the angular difference for the physical elevation?
Yes,
for
of
the
course.
mountain.
This
So that
is-
produces. So 1 second. So that produces a separate triangle that would be congruent based off of the angle. We force the congruency by using a separate triangle. It's not the same triangle. So your analysis and critique of that is invalid.
Excuse me. I see here in this sharing two triangles. Two. One with Pike's Peak with height of top 4,300 meters, and the second one in which the top of Pike's Peak is this 201 or 3 meters lower. Those are two triangles, and
Nice.
in Pike's Peak, in this intersection between vertical line on Pike's Peak and horizontal line from Efron is right angle. In any other triangle, as in right angle triangle, you can't use Arcus tangents function. Or you are able to use Arcus tangents in other as right angle triangle. Yes or no?
OK, ja vám to iba skočím, aby som to preložil trochu hľadisku. Praktický rozdiel je ten, že Jarda hovorí, že nemôže použiť Arcus tangents na iný uhol, ako je pravý uhol.
Já poprosím Jaroušku, pohni tím káčkem z nuly z placatý země na jedničku kulatou zemi. To popotahovátko horní, vlevo. Jarouši? So I want from Jarouš to make some,
all right.
some change in this model.
So you got two triangles here, right? You got the 233 for the flat Earth, right?
Yeah,
correct?
I have.
Okay.
Dude,
your thing's hard to see. It's kind of blurry,
there
so I'm just going through the clarifications.
I can't see it at all.
I got you. I'm gonna Stevie Wonder you or whatever, or Helen Keller. So he's got the triangle for flat Earth, and you got the triangle for a globe, which is 217, like that, 218, something like that, right?
Yeah, right.
Okay. Perfect. So those are separated by how much angular difference? Like the 233 minus the 218. They're separate.
27 minutes.
No. That's the full angular drop. That's the full angular drop. I'm talking about the drop over distance between the two predictions. It's only 13 arc minutes. So the difference between the prediction for flat Earth and globe Earth is by subtracting out the 13
in this triangle, but that doesn't matter. Jarušku, seš tady?
Jasně.
Tak prosím tě, pohni s tím káčkem na tu jedničku.
Káčko na jedničku.
Úplně nahoře doprava. That doesn't matter, Alan. Excuse me. Because globe Earth has no right angle in this triangle. That was my question on the parallel versus unparallel vertical lines and horizontal line.
We make
That
it parallel by
difference
subtracting
between
the
our
difference
model.
between the two. So even though
Okay.
even though you don't like our application of it, it's still valid, and we can use this whole thing to listen. That 13 arcsecond difference, if you double that, it comes out to be 27. That's the full celestial drop over it. So it's exactly valid and correct. You just don't like the outcome.
260 divided by 2 pi r.
Excuse me, Alan. You calculating arcus tangens between run and rise. Run and rise are total wrong in your model of globe. You have to use our model of globe if you wanna work there with. And in our model of globe, Jarušku, prosím tě, GE nahoře zmáčkni, jo?
Done.
Wait.
All right.
Okay.
All right.
This is our model of globe. Prosím tě, scale na 20. We can scale it again.
Yeah. You're not showing anything different than what we're showing.
Say me, please, where can I find your right triangle here in this model?
So listen, here's the thing. We're using central angle theorem to verify this. So can I screen share real quick to show you what this whole misunderstanding is about?
Very, very single and simple question. Please show us on this picture how you will make this triangle.
Yeah, so because this is a real, right angle triangle. Show us them.
Dude, for this, it's not going to produce one.
So hold on, is your argument that the 217 prediction is wrong, and then you're going to replace it with a different
argument
prediction?
This is
Theo. Excuse me. Our argument is that your Theo, your hypothesis, is just flat Earth prediction. You know, if the flat is flat, then it has seems to be so or so. And this prediction you did correct for flat Earth, hypothetical flat Earth. If the Earth were flat, then the elevation of the star on the top of Pikes Peak will be the same as on the reference home by occlusion time. Sure, it will be so on if the Earth is flat. And then you have second prediction. If the Earth is globe or were globe, then has to be that all in other way. So the two angles has to be different. And then you make total wrong triangle, total wrong function. You use total wrong geometric function because arcus tangens or tangens cannot be used in other as right angle triangle. That know we all. And you used this and you claim that your rise is the same rise as between Heffron home and Pikes Peak top minus this difference 203 meters. But you forgot the intersection between water level or between the heights above sea level, 2,073 meters. It is the heights of Heffron's home is the same by Heffron's home and is the same by Pikes Peak. So between top of Pikes Peak are those 2,226 meters. And if you subtract the 203 meters from the top of Pikes Peak, you must do that same with the intersection in this case, because the bottom of Pikes Peak has the same drop as the top of globe. And you simply forgot on this job on the bottom. So the amount of centimeters, of meters, of feet between bottom of Pikes Peak and top of Pikes Peak stay the same on flat Earth, on globe. It will be every time 4,300 meters from sea level.
Incorrect. All right. I'm screen sharing now, and we're going to go over this very meticulously. You ready? Because we're showing the same thing. We have two different angles derived differently. You don't like the way that we're doing our comparison, and you're trying to say that that's going to produce a different outcome, and somehow that the physical elevation is going to be the same. Let's be real. I just listened to you talk for a hot minute, bro. Let's be real clear. Occlusions are a physical process. So if we live on a globe, this mountain peak isn't 2 degrees and 33 arc minutes high in elevation. It's actually 2 degrees and 18 arc minutes because there's a 200 meter drop over distance here, which we can convert into an angle, which is 13 arc minutes. So real quick here, this is a simulator made by a globe lad who went out and did a measurement. So he made this, and the following the principles of the cell Theo did this, went out and made the measurement. So the idea that this leads to an incorrect result or what we're doing is invalid is retarded. I'll give you a link here. You can check the math for yourself on it. And then on top of that, what I was saying about the central angle theorem and why it's extremely important here is that's how we're deriving the drop over distance. That's how we're converting it into an angular amount. That's what we're subtracting it from. That's what we're making our separate triangle based off of. I know that you are using a different formula to derive the angles, but that doesn't mean that our angles don't work or that the comparison's invalid, because what you already understand is that there's two different predictions based off of the rise over run to the peak when you account for the drop over distance, saying that the actual sea level elevation difference between the peak and the mountain, the peak and the observer magically makes up the difference is insane.
Sorry, Alan, speak slowly, please. Speak slowly, please, yeah? Yes.
Yeah, I got you. Alan, I really need your answer on my question. If you use Arcus tangents for calculating your globe prediction, yes or no?
At first, we didn't.
We use central angle theorem to derive how much drop over distance there is, and then we subtract that from the rise over run to the peak from flat Earth. That creates the angular amount for the globe, which comes out to be 216 or 217. So if you have the number 217 and I have the number 217 for globe, then guess what, my dude? We have the same number using different trigonometric functions to get the correct output. And on top of that, this angular amount here, if we double it, that's the full celestial drop to the star, which we can verify by subtracting the true position at the peak from the true position at the observer, which comes out to be 27 arc minutes. So everything we're doing is valid. You just don't like the outcome.
Well, respectfully, unless you have a different prediction.
No. You are trying not to answer our question.
I answered it directly.
You have a very simple question. Please answer this question. Not go away from this. Just answer this question. It's simple.
Restate the question. Go ahead. Restate it.
Yeah, okay. Do you use Arcus tangents for calculating of globe prediction, your globe prediction, yes or no?
Only after using central angle theorem to subtract the difference.
Why?
So you use this function.
Because it gives you the amount to subtract for the physical elevation.
Function which
hey, guy, real quick. Let me ask you a question. What's the angle that you got for flat Earth for the prediction? For using rise over run, what did you get?
That was a simple question. Please, can you answer it? And
I've answered it. I've answered it multiple times. And I've answered it multiple times. Hold on 1 second. I
can repeat my answer. On flat Earth, will be both the angles on the top and on the reference house the same?
It's not what I asked you. I said, what angle did you get from the observer to the peak using rise over run, using the elevation of the peak?
Was first, please, could you answer it?
Oh, so we don't use tangent to represent the globe function. We use a tangent to represent the flat Earth prediction, and then subtracted the angular difference using central angle theorem from that to get the globe prediction. That's how we started. However, you can also construct a smaller triangle with that same drop to arrive at the exact same conclusion. So, sir, respectfully, unless you have a different prediction, your point is invalid.
Once again, you use wrong geometric function for wrong triangle. So your prediction for globe is basically wrong. And from wrong,
what's my globe prediction, real quick?
Once more, please.
What is my globe prediction? What angle do I predict for the globe?
Excuse me. Your globe prediction was -3 and 0 and 3 meters.
Who?
But
no,
it is not our model. It's your model of globe.
I have no idea. I have no idea what you're talking about.
Where show me your right triangle on the globe on our model with 2 vertical lines through Pike's Peak and through Heffron, and with 2 horizontal planes, one through Pike's Peak, second through Heffron. There is no solution for one right angle triangle, no solution for your formula. Excuse me. I can make right angle triangle there. Jaroušku, můžeš prosím tě to zase zvětšit? Klukům tam namalujeme ten trojuhelník. So we can go to your Excel. You use Arcus tangents only after many things, and I wanna from you only to show us how we shall construct this right angle triangle on the globe.
Right here, you paying attention? I'm screen sharing. Can you see?
Yes.
Okay. This is called. Okay, before we begin, real quick, what was your prediction for flat Earth for a rise over run to the peak? Was it 2 degrees and 31 arc minutes? I just need to double check.
For globe or for flat?
Well, it's only, I said for flat. So let's start with that.
For flat, we have had something between 2 great and 30 or 32 arc minutes.
Awesome. And then what angle did you get for the globe, you said?
Between 2 and 17 up to and 19, according to used method.
Fantastic. That's exactly what we get using central angle theorem. So again, to reiterate here, let's see here. Let me go to the diagram. Okay. You see this? You see this gamma, this half gamma term here?
Yeah, I see that.
All right. Half gamma is always going to be half of the full celestial drop amount. So for drop over distance, we can use that angular amount, right? And we could also convert it into meters because we have a distance established.
Can you show me the distance on the first image?
Let's see. Right here.
Here.
This arc length here.
A moment. So you are using arc distance, not line.
We can do arc distance. We can do the cosine between latitude points. It doesn't matter.
Moment. You are using Haversine formula, therefore.
Sure. We can use whatever formula that we want. Yeah.
No, we can.
Sure, you can. But the Haversine formula, it is formula for calculating distances on the sphere surface.
Was your argument that the distance on a sphere and a plane would differentiate substantially here, or not?
Yes, of course. I don't know how your map of flat Earth should be like.
Okay. Real quick. The difference in distance between a chord and the arc length here for 50 kilometers is 14 centimeters. So we don't dispute the distance or care.
Yeah, that is right. And the difference between this distance on the sea level and in 2,000 meter higher is how many? How much? Because Haversine formula counted those distance on the sea level.
Bro, the
Are you saying that we
elevation,
didn't account for sea level? Because we definitely did.
And
both
you cannot
both
use the
the
same distance for flat and for globe, because on flat is this distance independent from height.
You said it was 13 centimeters. So you want us to use a 13 centimeter longer line? Because we could. It'll change our prediction by about a thousandth of a degree.
I'll do you one better. We actually can do. We can hold on a second. We can actually do plus or minus the average of, like, so if we assume that there's like an error in the latitude and longitude and whatever, we can add plus or minus 5 arc seconds for a bunch of stuff. We can add plus or minus 15 to the altitudes and peaks. Hold on one second, dog. 1 second. Dude, I'm in the middle of explaining to you something, and you're just going to start talking over to me, and I'll just let you know ahead of time that's never going to happen. So real quick, if I'm in the middle of speaking, don't start trying to speak over me. So we can take the distance and add plus or minus 224 meters to it either way, completely compensating for the 14 centimeter difference. It's not going to change anything. You already said that the angle difference between flat Earth and globe comes out to be 13 arc minutes. So that's going to produce a 13 arc second time for that star to be occluded. That's the difference between our two predictions. You trying to say that, oh, it comes out to be the same somehow is like, you're in serious error, dude.
So can we go back to the first image? Can I see the triangle there? I know what you take as run. Where is the run here?
The distance is the arc length. We already went over that. We just went over that.
Dude, if your disagreement,
man, why you run every time away from this image? Show me your triangle here, please.
Yeah, we're showing you this triangle directly, and you're ignoring it like a child.
We're showing you this triangle here, and listen. Well, how we use this triangle here, we get this half gamma amount. This half gamma amount is going to be our dropic. In this case, for this distance, for this arc length, it comes out to be 13.42 arc minutes. Please, for the love of God, we subtract that from please stop so I can explain the process. If you interrupt me during if you interrupt me during explaining it, you're not going to understand. It'll be super hard to understand it. So we got the 13 arc seconds from our half gamma. We subtract that from the flat Earth angle, and we make a new triangle that represents what the elevation would be for the globe prediction. So we've arrived at the same elevation. We've arrived at the same prediction differences for the two. So our math's fine. We can verify the full angular drop and stuff by the positions in stellarium. So what exactly is your contention?
Can you one time, not running away from question, where is here the right angle triangle in which you calculate arcus tangens?
We don't use a right angle triangle for the
question. Where? Show me
for the last time
of this triangle.
For the last time, we don't do that. We take the angular difference from central angle theorem, and then we subtract that from the flat Earth prediction, which creates a new triangle, arriving at the same amount that you just confirmed for us. So what we're doing and what you're doing and what we're presenting, we're not saying we're mathematically doing it differently, but we're arriving at the same differences for each position. So you've reached the mutually exclusive prediction for flat Earth, which is 230, 231 or whatever. And then globe Earth would predict about 217 to 218. So there's nothing here that's invalid. You keep asking for where's the right angle triangle for this. And I'm telling you, we don't use it for that. We use it for the half angle gamma amount, which we can subtract angularly from the flat Earth prediction to make a new triangle. That's what Shane's whole presentation was about.
No. We have all your Excels. You have everywhere this arcus tangens from rise and run there. There are fairy tales. Guys, what do you explain now?
Oh, okay. Guy, hold on one second. You made a very specific claim about the arctan rise over run. Let's take a look at the formula function here. What does this say? Can you read this? What's this say? That says main flat Earth angle minus F10. Okay, this is the flat Earth angle. This is our 230, exactly what I said. And then we're subtracting the half gamma, which is derived. How did we get half gamma real quick? Oh, we did 180 times the distance over 2 pi r times the radius of Earth. Okay, so we did exactly what I just said, and everything you just said about having the spreadsheets and we're doing it wrong and we're arctaning the globe is incorrect. Provably by just opening the spreadsheet and looking at it. I'm hovering over the formula for it.
And what do you compare at the end in your Excels? Angles or apparent or so-called heights?
What's your question?
By comparison, you operate just...
You want to acknowledge the last 10 minutes was all fruitless nonsense and that we actually had the same prediction the whole time before we jump to a different topic?
What,
Yeah,
please?
sorry, but you haven't used a correct model of the globe Earth. You made some simplification or some assumption or some drops on whatever, but you haven't used the correct globe Earth model for comparison.
Did you say that we arrived at a different angle for the predictions? Did you say that was wrong? Did you say that we can't use stellarium to verify the full angular drop and verify the half gamma amount that we subtracted for? So real quick, this amount right here that you guys think matches a terrestrial theodolite measurement of about 219, accounting for refraction, you think that this is, we did this wrong. And you specifically stated that you have all our formulas and we're arctaning the globe and we're looking at subtracting the central angle theorem or the central angle half gamma amount from the flat Earth prediction, exactly as we said. So I don't know how so if you arrived at the conclusion that we're arctaning the globe and you're trying to force this, where's your right angle triangle thing? The error is on you.
So you haven't used a correct 3D model, have you?
Real quick, can we just acknowledge that we have the same angles and then there's no error? And there's no error?
Was a really simple question, yes or no?
Oh, it was a really simple question when I asked if we had the same angular predictions for flat Earth and for globe Earth.
Sorry, have you used the correct 3D, or not a 3D, but a model of the globe Earth, yes or not? You made some assumptions with the job.
Buddy,
so my question is really simple. Have you used this, which is on my screen right now?
I see a screen.
I'll do you one better. I can use stellarium to verify the central angle.
Sorry, this is not about stellarium now. I'm just asking.
You just asked if I 3D modeled it, bro.
Okay, was just said something what I didn't want to say. I'm talking about model, and my question was, have you used the correct model of globe Earth for your calculation like this? Because what I see, you made some assumption with the drops, with the triangle simplification. This is real model of the globe Earth. Have you used this or not?
Have I used the thing that you made customly? No. Does it produce the exact same? Dude,
I'm not. Hey, Alan, please calm down. This is, of course, this is a model we've created, but it's based on a globe as is described. So have you used this? I mean, not particularly this.
In mathematical formula, yes, that's how we arrived at the same amounts.
No, you didn't.
You're saying that we got 217, but we did it wrong, but you got 217, but you get it right? Is that your position? Is that your current argument?
Sorry, but you used for the comparison wrong model of the globe Earth. So then your assumption or results cannot be correct.
I'm just trying to understand your position.
Cannot.
Right? So what I said was correct, right? We arrived at 217 incorrectly. You arrived at 217 correctly.
Hey,
that is your current argument?
You're going through the real numbers right now. My question, or our question, was very simple. Have you used the correct model of the globe Earth for your calculations?
Yes. Yes, we have.
No, you didn't.
Model. Yes, we did. Over and over again. In fact, we've used so many different versions of the globe. That's where the globe drop prediction formula variance comes from. We have seven different iterative processes.
Hey, we are not talking about the drops. I'm just asking you if you take into account that the lines from the peaks to the center of Earth are not parallel, that the angles from one peak to the other peak and vice versa are not correct or are not the same.
Have you met my friend Central Angle? That's
Earth,
bro. Yes. This is what all these equations represent. So you showing it, you showing it in graph form is, and then asking if
we're turning to your picture, but
yes, this picture represents your graph, bro.
No, we didn't find the very simple question if you use the correct model of the Earth with all assumptions, with all things which are described during the history and during whatever. So you
sounds absurd unless you have a different prediction. This seems like a lot of grandstanding.
And then we can go.
Conclusion. Unless you have a different prediction, I don't understand what your point is.
My point is that you haven't used the correct.
So we've used an incorrect model to arrive at the exact same correct conclusion. That's your position.
The correct result at the end. So please, okay, use.
Jaroušku, máš tam někde tu stránku z Excelu, kde srovnávají výsledky těch predikcí? My se tady dohadujeme o úhly, o který tam vůbec nejde ve skutečnosti. Oni nikdy úhly nesrovnávali. Škoda. Zkusím poslat, jo? Klidně pokračuj.
So, and so because we haven't found an agreement or you haven't answered so far the very simple question.
We've answered 7 times.
At the beginning. No, you didn't. Now we can maybe go.
The answer to your question is no, and then we explained what we were using and how we arrived at our conclusion.
No, that's fine.
And then you keep re-asking us the question and saying that we're not answering it. And then that guy just said and then that guy just said we were doing something completely different on our spreadsheet. I pull up the spreadsheet, we look at the formula, it's exactly what I said it was and not even close to what he said. Like, how do you
you guys do this juvenile dance where you pretend we're running away, but we're here telling you what we're arguing, and you're pretending that we incorrectly arrived at the exact same solution. It's a very weird argument and position. I thought we were going to be mature adults and have a cohesive.
If you don't have a different prediction from us, I guess we can just wrap it up because you're not even explaining how you got there, dude.
Shit's in, shit's out. If you don't have the correct inputs or things you are calculated. So you cannot have.
Well, luckily we arrived at the same mutually exclusive results on our calculation. So I guess our input is good. If our input matches your input, it's good. It's the same. So if my input matches the motion in Stellarium, then we're good.
And later I can show you that this doesn't work.
You know, other people have used our method and reproduced it. You know, a Globe Lad made a simulator and then got the measurement and then tried to say that it was like mutually exclusive to a globe after using our method to do it. So like, go ahead. What's your next question? How many people? Bro, I bought a C-Star and me and Kat did 2 measurements. Our buddy Goose, who lives in Canada, did one. The Globe Lad named Jesse did his own.
There's 52 now in the database and repository of separate observations with different distances.
I mean, how many people made this observation and these measurements around the globe? Totally, there's minus 100.
There's probably close to 50 in total if you count all the peaks and occlusions, or you count all the occlusions. Oh, I'm sorry. Mike, Jesse, me, Goose, and I think that's it. So 4.
Wait, you're be so precise. I said plus minus 100. So it's about 5 people.
Just to be clear, you're saying that we're still right, but we're right incorrectly. That's your argument right now.
I claim that the celestial theodolite doesn't work. At least
can't substantiate.
It doesn't work in certain cases I made. And I can show you. Actually, it proves that Earth is not flat.
Did you rehearse this beforehand, bro?
Well, let's get to that because this is going nowhere. We've already established that your ability to represent our position is not not adequate, dude.
You were not able to answer a simple
buddy,
question for
buddy,
45 minutes.
We answered it 100 times.
Buddy,
We answered it 100 times.
not only did
No,
we
you
answer it,
haven't.
we told you and showed you exactly what we were doing to derive it. That guy said we were doing something different. I showed you the exact formula from the spreadsheet. So you guys are literally just making things up, and then now that we're here, you don't really have an argument.
Yeah.
So do you want to get to something? Do you want to get to something substantial?
You were running away from question many times.
Juvenile tactics aren't going to work.
Many times.
We don't
Many times.
Yeah. So there's this thing called rewind, and people can see where we said exactly what we were doing by subtracting the central angle amount from the flat Earth prediction to arrive at the same amount. They can also see where you said we were doing something different and where I showed in the spreadsheet that we're not. So your refusal to acknowledge what we're doing and misrepresent us is just, that's for your own, that's for you guys. You can do that on your own. You don't need us here for that.
You have your model of flat Earth and you have your model of weird flat Earth, and you call the second model globe model. And we have our model of globe, which is 100 years old. Many and many thousands of people have measured them.
So your globe model predicts what our flat Earth globe model predicts exactly.
And many thousands.
So you're arguing that it's different without it being any different is weird.
You are even not able to calculate distances between those 2 points without our globe model, without Haversine formula.
Calculating distances using a spherical coordinate system isn't mutually exclusive to either model. It's a coordinate system that computates distances based on spherical coordinates, which are latitude and longitude, using the radius, which defines the coordinate system. Now, what you have there with that is hold on 1 second. 1 second. This is one second.
On the sphere surface.
Ooh, see, you're adding an additional term.
Okay.
Hey, please do not talk over me, man. I really you don't need to do that. So here's the thing. What I was just explaining to you is that it's a spherical coordinate system. Latitude and longitude is defined by positions of the stars. Now, your assertion is that represents the terrestrial sphere as well. Now, the coordinate system itself and calculating distances based off of that isn't mutually exclusive. It's an internally consistent model because units of measurement are also derived from a length of a longitude line. So it's not going to produce an incorrect distance because it's internally consistent. What we're doing, by the way that we're using these quote unquote globe tools, units of measurement, etc., is doing an external test of the internally consistent system. So if this mountain that you're showing here, it has no physical drop over distance, then when a star gets occluded by it moving at its 15 degrees per hour, that angle is going to get occluded sooner because that mountain peak is actually higher than what it optically appears to be. When you have a globe Earth and you have that drop over distance, well, you subtract that from the angular elevation of the peak relative to you. So you just subtract that out, and that's how we get the 217 to 219, depending on if you want to account for refraction and whatnot. Now, that's the physical elevation for that peak. So when that star is coming down, there's no 13 arc seconds of physical stuff to block it. So it's going to take longer to get lower in the horizon before it gets blocked. That's it.
Okay. So you claim the coordinates on our spherical Earth were made according to star's position. Okay, which star stays and when in the zero position?
All of the ones that are in the
0 point of the system.
All of the ones that are in the nautical almanac, they take zenith measurements on the vernal equinox of where they are.
Which star?
That's what the whole thing was based.
Where the people have said it is. You had claimed that the stars were on the very beginning of this coordinate system. I asked which star was that which determines the 0 point of the system.
The ones that they use for a cell nav. There's 45 of them or whatever. I think they started with 14. I don't know the exact ones. You could look it up in an almanac. It's kind of irrelevant.
Because no one was at the first beginning. Because again and again, it was made in other way. First was the spherical system on the Earth's surface, and then we have measured the zenith position of stars, not even of all stars, as you say right now. And first of all, when next time will be the stars in the same position as today? Simply question. When next
300
time?
A year from now? A year from the day they were?
Yeah, for this time, exactly this time now. When again can we see the celestial sphere in the same position of stars as now?
A year from now?
No, never. Never. Look in Nautical Almanac again, please. Never. And do you know why? Because these stars are continuously changing the position between themselves. You can laugh as you want, Shane, but it is so. Each star is moving again, sky, background.
Respectfully, if that were true, they would have to change the positions in stellarium and stuff for latitude and longitude, because that's what defines them. It's based off of the time in which they return.
No.
Yeah.
They have not.
Yeah.
Because
all right, dude.
The star coordinates.
Hold on. The whole point of bringing this up was Haversine wasn't used, right? You said we can't use Haversine. We went into coordinates. I just want to clarify your position again, that you think that there's a difference between the length of a line on a sphere versus flat Earth for this specific analysis, right? That's why you said it was invalid. Is that correct?
Moment. Can we stay by the stars for now?
No.
Thank you, therefore. Can we stay by the stars? Because it's interesting debate. You think
so you want to do a different debate than the one we came here for?
That if that were correct, that we have to change latitudes and longitudes because the stars are moving in the sky. We know how fast is moving Polaris against sky background. We know Barnard star, how fast, it's the fastest star, by the way, how fast is he moving against other stars. We know that the stars changing the positions in this grid each day, each second, each year. So these stars will be never again in the same constellation as today. Never. So it's ground why your cell theory is unreplicable, because the star that you have measured will never be in the same position, in the same date, in the same time. Never. No in year, no in 10 years, no in Platon year. That are 25,000 years and 600 years, I think.
Celestial navigation is based on the principles of angles equaling time. If there was a change in their physical position, that would change the time in which they arrive. It would literally change cell nav every year, like you're talking about.
Therefore, we have for every year new nautical almanac with other numbers, with other GHS, with other LHS, with other areas time. That the ground. Did you see nautical almanac from year, for example, 1900 or 1905? Look in, please. Look just on Polaris. How away from North Pole Polaris was
buddy,
in 1905.
If you go to Mike's house,
look at angels between
Stellarium
Polaris and Regulus.
You can play out Stellarium for a year. It's going to return to the same angle.
No.
All right.
We played it in our own team. That's not true.
They have the same angle we have. There's no different angles, so I don't know why we're
not true.
Yeah.
You can
have a different
not made in Stellarium. After a year, the stars will be not in the same position.
You said we can't reference a true position? That doesn't work? Is that what your argument is now? I
don't even think he said that, bro. I think he's just saying stuff.
I'm trying to dissect an argument from what you're saying very slowly, but I'm struggling. If you could help me out, what is your actual argument at this point?
What, please?
Are you just lecturing at us?
No. I have asking.
Yeah.
When
So
comes
so listen,
You
I got
you
about 10
say
minutes
after
before I
year
have to go
you
do
have
something
lost,
else. So if you got any good
you have
arguments that you
said
want to
we
whip
have
out, send them.
that and that to change, and now you will run away again from question.
No, we're not running away. We answered
No.
your question
Your
7 times,
I-
but you
claim,
acted
no,
like a
your
child and
claim about
pretended
Star
that we are
was
running
wrong,
away
and
directly
not
while we were
true.
answering it. And then you pretended that we didn't answer it 3 more times when we kept referring to our answering of it. And again, the answer is no. We're not using arctan on the globe. We're using arctan for flat Earth. We're subtracting the angular
It's funny.
difference gathered by the formula for the
Dude,
globe correctly.
it's funny.
And
It's
then
funny.
we're using that
He
as a
said-
prediction.
It's
Dude,
funny. You
is
are
it-
not able
That's the
to
answer.
Is it-
answer
That's the
the
answer. That's
question
the
about
answer right there.
stars
I
and
just said.
their motion, so you go back to triangles.
Dude, if they
When I
okay,
ask
listen.
of triangles,
If you're
you're
correct about the
running away
stars, if
for
you're correct
stars.
about the
Cool.
stars, if you're correct about the stars, then I'll gladly say I was mistaken. But let's get back to the actual point of the
Okay.
art. Then let's get back to
Open
the actual.
Stellarium,
let's
we
get-
can check it. Open
let's get
Stellarium,
back to-
please.
All right.
It's very simple.
Kterou
The stars
stranu
will
můžeš
never be
odebrat
on the same
Stellarium?
position.
We can check it.
All right, installing it now.
So okay, I'm very glad you said this.
Tak, kdo bude sdílet?
Alan to sdílí. Alan shares it, sorry.
There, I should be sharing. I'm installing it now.
You can go in web version. It's Stellarium minus web.
Okay, second.
Yeah, okay, I do same on my computer.
Choose whatever star you want.
Just
Oops. 1 second. Let me get Mike's coordinates.
Yeah, okay, sure. And you can take which date and which time you want.
Yep. I'm just gonna pull it up to Pikes Peak for this to keep it with Aquarii or whatever. So that's the one we're all familiar with. Just give me one second. Pulling it up.
No problem. No problem.
Convert. What is it? Peak latitude. And then peak longitude. Oops. Should be. It won't let me. 5 0 4 4 4 4.
Daroušky, ty to máš taky, koukám, viď?
Yeah.
5. Okay. Next peak. And it's custom time. What says UTC? So annoying. UTC 7. UTC minus 7. And then time. We go to this. 20.
Were they saying that stellarium doesn't corroborate any of the things we say it does? Is that why we're doing this?
No, I was saying that the angle would be the same. It would return to the same path or whatever, and they were saying it wouldn't. So we're gonna verify the outcome of that now.
You're going to start from the Pikes Peak observation and then just go exactly 1 year. Okay.
You can choose whatever place you want and whatever start you want. It doesn't work. It changes the start, changes position every year.
Okay. Well, if I'm wrong about that, that's fine. We will. I'm not going to be like, no. I was pretty sure it didn't work that way.
Yeah, but that's fine.
Doesn't change the
was
argument
one
at all.
of your predictions which came wrong again.
So you're saying that doesn't affect the measurement though, because like we know where it was. We know where it was going to be at that time, because angle equals time in cell nav. So even presumably, like if it does change with the updated times, you would still be able to make the same measurements based off of the elevation differences.
The globe would be exactly the same wrong.
Again, so sorry.
But your goal is to try and make Alan wrong and not to refute any of the celestial theodolite arguments or data. Just to be clear. So I'm trying to refute the right thing, and it's hard to refute what I'm not clear on.
Just to be clear, results from bad or wrong used formulas, there are nothing to discuss about them. From
wrong formulas that arrived at the same prediction as you?
Bad results. We say that many times.
It's a good thing our formulas are correct.
Go on with this star.
So here we are at, let's see, appearance. Let me turn off refraction. Oh, atmosphere. All right. So we got 233, and we got what's our ASI? There we go. So we got an ASI. This is our ASI. All right, and then we go 1 year out. Oops. 1 year out. Boom.
I need grids so we can see where it is, see if it changes. Otherwise, cool.
Oh well, I was just going to go off of the azimuth. So we're at 1 year from now. We have a new ASI
and new elevation.
New elevation. Oh, we do. You are correct.
Yes, of course. I know.
Is that very gratifying?
Well done. Okay, so let me ask you this. So
we have sextant. We was on the sea. We have navigated with sextant in real life. It's work, of course.
Dude,
but on other base, as you think. Therefore,
listen.
Need to be new almanac for each year. Okay, go on.
No, that's totally fine. Thank you for the correction. And on that note, so every year then you would just use whatever the position's going to be at that time, because celestial navigation, as you know, is based on angles being equivalent to time and vice versa. So if you have the correct updated time, then you should be able to make the same prediction, but it just will be at a slightly different time, because the elevation at this time is going to be different. So we'd have to wait, instead of it being the exact same time. We would just have to wait until it gets, oops, it's the wrong direction. We would just have to wait till it gets lower in the horizon. So we would.
Sorry, Alan. That is your mistake again. You never found the same star in the same elevation continuously with the same azimuth. It's impossible. It is simply impossible, and that don't work. As I show you this one issue, we can show you the second two.
Well,
you don't find time in which will be the star in the same azimuth and elevation as now.
Listen, that's still fine, because when it hits the peak, that time is just going to be relative to where it was at that time of the year. So if the change exists, as you said, the methodology is still sound and preserved. You could still do it based off of the new time, and you would just have to use a different star if it gets so far out that it's not going to hit that peak anymore. That doesn't.
How you check it that the methodology is correct? Through which measurement, except of this methodology itself?
So all of them. You do the prediction based off of what the
validate method through this method itself.
Bro, it's validated through the timing of the occlusion, right? Because what we produced for that angle for flat Earth was 233.
Is part of the method.
Yeah. So listen,
No, we have
inclusion.
independent
You are trying
corroboration from
to
Stellarium.
confirm the method
Listen.
by this method itself.
Listen,
Oh.
we have the time that it was occluded. We reference where the star was, and that angle matches the flat Earth prediction for the elevation of that mountain.
Also, corroboration from globe tools like Stellarium. That was the whole point he put forth in the first place, was to use the globe tools to prove you wrong. So to say that we can't use, I mean, obviously we're using Stellarium as a tool, as a reference, so because you wouldn't disagree with it, right? That's what the whole reference of Stellarium was, the true position.
The stars matches your prediction, and your prediction sounds for me. If the Earth were flat, the two angels will be the same, on the top of peak and on the house of Dr. Heffron. We will say so. How have you checked it if the two angels are really same?
Stellarium also actually
How did you measure it?
Stellarium actually also confirms our angle. Our angle from our prediction from the formula that you say is wrong, Stellarium independently comes to the exact same prediction as we do. So that's how we verify our stuff. It's not self-iterative. We're not using a self-contained system. We have an outside corroboration. Go ahead, Alan.
Stellarium showed you the same angel from Heffron's house as from Pikes Peak in the exact same time? No.
No, different elevation. That's
you
the point of this.
Ask Stellarium on the angle by Heffron's house. You
of course we
didn't
did.
Ask.
Of course we did, and it's in our math verified by central angle theorem. So we can actually do this right here if we want to know. Yo, real quick, did you know if we want to know where the star's at, all we have to do is apply the full 360 times the distance for the drop, and we'll get this number right here, 206. We'll get the position of the star.
No.
Yeah.
Yeah.
Buddy, that's what all this is.
The angel in Stellarium from your position on Heffron's house. You calculated it. Based on your calculation, based on your premise that the two angels are the same. How have you checked it? Really physically check it with some measurement that the angels are really, I speak, that the two angels are really the same. I'm not so fast as you in English because it's not my native language. I need time for translation, so I make some pauses, and sorry for that. You can think I have ended, but I have to construct my translation in my head, so these pauses can be there. Sorry for that, but let me bring my speech to end. Thank you. Thank you. So you have not read the star elevation, the 3-9 Aquarii, from position on Heffron's house or before Heffron's house. You didn't read that. Didn't read the apparent elevation, didn't read the real elevation, didn't read the azimuth at the same time as from Pikes Peak.
I absolutely did.
How did you check that the two angels are the same? I can make prediction for globe.
Yeah, because we send
you the file.
So listen, guy. Listen.
Exactly so good as yours.
You know how you said earlier that you've been over.
Finish.
Okay. You know how you said earlier that you went over the spreadsheet meticulously and you know all about it? Well, in this spreadsheet, there is a thing in the data sheet all the way over here that has links to Canva. All the peaks and stars have Canva links. When you click on the Canva link, you can go over here and see where the star was at Mike's house with refraction on and off, and with the correct barometric pressure for the celestial refraction or astronomical refraction correction. And you can also see where it was for the peak. So the exact thing that you said we didn't do, we did. And this is based, if your contention would then have to be that Stellarium's wrong, that this angle for the observer isn't correct, because that's exactly what we're comparing it to. And what we found also is, via the old central angle, we can subtract that from the position of the star at the true position, and we can get where it is for the observer. You can see the difference right here comes out to be 0.010 arc seconds. So it's spot on. And anytime you change measurements, we have that comparison for the self-validation to make sure that we're not straw manning the globe and we got the stars in the correct position. So if this number ever exceeds anything over, partial parts of an arc second, then we know we're doing something wrong. It never does.
So you took Stellarium. You have read both angels, but you have taken as correct only one, because you don't believe Stellarium that the second angel, that one from observer position, is correct. Excuse me, Alan. How did you say it? Yeah, I know. You like Stellarium, but you don't like all of them outputs. Sorry.
Yeah, so the reason...
How have you checked it? Which one of these outputs from Stellarium is the correct one? How did you check it?
Because occlusions are a physical process. So if the mountain gets occluded, so if the star gets occluded for us over that distance, it's either going to get occluded based on the physical intersection at the angle that's closer to flat Earth or the angle that's closer to globe. So we predict for the physical elevation 230, and for a globe, it would predict 216. So the star should be lower in elevation when it actually gets blocked, but it's not. So that's it. So we're using the physical process. A refracted image doesn't cause an occlusion. So trying to determine it from the observer's location tells us nothing. That's why we reference the where the star was with respect to the peak, because that's where the physical intersection is going to occur to cause the occlusion that the observer saw X amount of distance away.
And if we will measure the angle between Pike's Peak, for example, and Dr. Heffron's house from both sides simultaneously, one measurement from top to Heffron's house, second measurement simultaneously from Heffron's house to the top of the mountain. So it can be involved from refraction, but from both directions, the same involving.
Right, but
if the Earth is flat, the two angles have to be the same again. From Pike's Peak to Heffron's house, it shall be in minus, and from Heffron's house to Pike's Peak should be the same angle but in plus, about 0 astronomical horizon. So can we check if your method
that'll
is
never
correct?
be measured. That's only an indirect reference from the conclusion, right? That the angle will be the same. We're only inferring that from the conclusion. We're not measuring that. For you to keep repeating that is kind of crazy, though. Right? So
we have measured so one angle.
Well, no, so we're not using the angle from the observer to the peak. We're predicting the angle to the star from the mountain. That's the purpose of our mutually exclusive math that I showed very, very much in the beginning. That prediction for the arctan of rise over run for us was to the angle from the star from the peak. The angle from the observer to the peak is never used in any of our predictions, none of the comparisons, and has zero effect on the mutually exclusive evidence. So, did you want to keep talking about that, or did you have some actual mutually exclusive globular evidence that would arrive at a different prediction so we can actually get somewhere?
Moment. Okay, I have said we have measured this one angle, not from Heffron's house to Pike's Peak, of course, because we are living in Europe. We have made it here in Czech Republic, between one town Olomouc and one peak Prague, and it was simultaneously measured from top to town and from town to top multiple times, and we are pretty sure that the two angles are not identical, are not the same. So
they will never be observed the same. So you're attacking a straw man. No one cares about what you're talking about. We're never arguing that they're going to be the same. We're never saying that you can go there and measure and they're going to be the same. No one has ever said that. Why would you attack that argument?
Once more, please. Don't make judge about argumentative fouls, etc. I didn't make any, no one of them. If you want debating about argumentative faults, etc. Okay, we can. But what we take there from, I don't know. I have said, we have checked it out. If your method is valid, so long that those two angels have to be the same. We have protocol in our public section in English for you. And it is clear, measured, that those two angels are not identical, they are not the same, and they are pretty near to globe spherical Earth. And we have predictions in our models, in GeoGebra, in Excel, etc. You got all of our models. Any time after our streams, we got all our models in our public section. And you can check them all, as we made with your cell theory. We are pretty sure that your globe model used in cell theory is not the most valid one. We are pretty sure that if we use correct one, we take the same correct predictions like you took. Because cell theory is proof of nothing because of these elementary mistakes.
So nothing you said actually was in relation to what we were arguing. You attacked a complete straw man. To say that we would go to the observer and measure a different angle with a theodolite is not our position. That's not the purpose of the method, nor would it have a mutually exclusive outcome, which was the whole purpose of the beginning presentation when we showed you the occlusion time as a physical event to be the thing that told the difference. And the difference between the two times, again, for everyone, for the audience, was the difference between flat and globe over that difference. And that's the exact amount that was missing from the time of the actual observation that happened 52 times that concurred. The actual geometry of Earth is planar. That's what we're saying. Now, you're bringing into how we would measure two different angles and compare them. That's not our position. That's not our argument. It has nothing to do with our actual method, and it has nothing to do with the results. So you can keep arguing that if you want.
Thank you. Thank you for stopping judging our argumentation. Thank you, therefore. Ironically, of course. That's all to this thema. I did not say that you have measured those two angels. We have checked it, and our conclusion is that works not. That's all. And we can check what we want, how we want, included of your cell theo methodology, because we are arguing exactly about cell theo. And for sure, we did our checks about them. Otherwise, we were not able to discuss with you. And our checks saying the two angels are physical different. Your prediction for flat Earth says the angels are the same, or not. The angel from Dr. Heffron's house is not the same as from top of the Pike Peak to the star in moment of occlusion. Shane, you wanna say these two angels at moment of occlusion are not the same of flat Earth?
For the apparent position, but that's why we reference the true position, because it's not affected by refraction and it's considered to be the light source. That's what moves at 15 degrees per hour. And then they add refraction, based on where that position is to come up with where it's at, where we optically see it. So we don't predict that having a camera or whatever on top of the mountain to record record in synchronous with the occlusion from the ground observer. We don't contend that would produce the same optical effect. It's not our premise at all, if that's what you're saying. And then on top of that, you were saying that, you guys measured it or whatever. do you mean like you're referencing what a optical like regular theodolite would measure and saying that the cell-theo giving a different angle is incorrect? Because that's our premise is that the optical angle is in contention, right? We can say that the angle is that the mountain appears smaller because of Earth curve, or we can say that there's some optical effect that's causing it, and the only way to determine that would be which elevation actually blocks starlight, because occlusions are a physical process with a geometric intersection with a light source. So if we reference the true position as the light source, that's all we're doing. So any further analysis of like comparing it on both sides and all that, that's nothing to do with what we're proposing and doesn't have anything to do with it. So.
No, that
but
has
you
everything
you
to
are
do
well,
You're
you
free
are
to keep talking about it.
you are free to do that. And if that's the basis of your argument, I think we could wrap up if you're ready. Or do you want to get like final thoughts and stuff or what?
Once again, please. I'm not so good at English. Sorry for that. I'm better Russian or German or Czech or Slovak. English is my weakest language. Really sorry for that.
You just had weak arguments. You had pretty strong language, though, to be honest. So I don't think the problem was language.
Can you repeat your last sentence, Alan? I didn't understand.
I said, do you have any like other arguments, or do you want to like do closing statements or something and wrap up, or what?
My closing statement is really simply, but I take place for Jaroš at this moment. Jarošku, prosím tě, je to tvé. I'm going for water. I'm back in seconds.
Yeah, okay, so welcome again. Actually, maybe time is running, so let's go, let's say, to my, let's say, a simulation. I made some simulation of occlusion of some stars for similar or some of mountains here in Europe. One of my favorites is measurement from actually the observation of the star occlusion from Gran Paradiso to Mont Puri. And as you can see, I'm looking from left to right, and I'm looking in a negative angle. Okay. I thought, actually I heard that this is not a problem for you, so okay, I'll continue. If I compare it with flat Earth predictions, I'm getting a difference about 0.3 minus 0.34 degrees, which is in your favorite big height difference, 188 meters. But that's not all. My favorite part is that in that case, and I tell again, I'm doing this exactly according to your proposition. So in that case, that dimension star should be about 255 kilometers away from the peak on a ground surface. So, okay, guys, I'm sorry, but there's something wrong. Of course, I give you all my let's say calculations or data, so you can compare it, you can simulate it, you can test it.
Cool.
But
please
definitely, this is only one example, because as I said, time is running. So, and you like this, it's a black swan. So if this doesn't work, so all celestial theodolite assumptions are wrong.
Nice. Well said.
So, if I can, we let you last word, your two, because you are our guests. So you have to have last word today. So my last sentence is very simple. I understand that we don't came to common position, to common solution, to common resolution. Okay, we were awaiting it. I was honored
Okay,
to
if
say,
I may, my last word. The debate wasn't so hot as I expected. So thank you guys. It was, let's say, in our limits. And if I'll have any other opportunity to debate with you, I'm in. So thank you very much. And your last words.
Thank you. Right.
And my last, firstly, then you have the last 2 words. Promise. So from my point of view, you have said it. Method based on wrong used formulas can bring only wrong results, and these results can imagine good results. It's okay, but the method full says nothing about them. That is my opinion. I have seen your last update about solar eclipse, and excuse me, at this moment was the to see from South Hemisphere to which was also impossible according to celestial theodolite. But okay, all our models, all our arguments will be in our public file. Link is, I think, yet is this link already under our stream in description. So as Jarosz, it was pretty good surprise for me. You are cool guys. Of course, we don't understand us in all aspects, in all our words. We were both sides, I think, awaiting it. But it was cool. And yeah, I am ready to see you next time again. Thank you for visit, guys.
Thank you. Cool. So in closing, I'm skeptical of your guys' ability to discern anything about what we're doing, since multiple times throughout this, you guys lied, said that we were doing things in the spreadsheet that we weren't doing. I showed you directly, didn't even answer it and address it or admit that you were wrong about it. When you showed me something that I was wrong about, I accepted it. And also the thing I was wrong about, you could use in a later year for referencing in the correct time. So it doesn't actually change anything about the argument. And in addition to that, you keep saying that, shit input, shit output, but our outputs get the same. So we're doing the same thing. You don't like the way it's being represented because the occlusion times give a conclusive, mutually exclusive outcome, which can determine the shape of the Earth conclusively, rather than basing it on apparent images and just optical measurements. So using the geometric occlusion, which is facilitated by the physical intersection of a light source and a mountain peak, we show that the elevation of the light source when it got occluded it doesn't match what the globe would predict. And none of the math that we got is incorrect. I showed multiple times how we verify the consistency with the star's position in Stellarium. We couldn't steelman the globe any harder if we tried.
Aha, tak už je to konec. Kluci už jsou tady.
Man, I am super sorry.
Tak už je to
I
konec. Kluci už jsou tady.
I am super sorry. Man, I am
Are you speaking, Dom? I can't hear you.
Yeah, there was echo.
Gotcha.
Man, I am again super sorry. This was there was such a tragedy and also such super comedy show. Like, to be honest, like for us it was super hilarious because like almost every single stream that we have, like this Czech English presentations, they're always like make fun of my English. They're always like laughing me. They're always like telling me that I like talk like a Tarzan or something like that. And like for us, it was kind of like karma, I would say, even like to have a chance, like the translator, like dude, he like surrender in after like 30 minutes. Then like there was no translation from their side, so I was like translating pieces and bits, and we will definitely do like a watch party after. But like it was hilarious. Like their whole argumentation was that like you have a same numbers, but you get to the numbers different way. You show them how, but they were like, "Oh no, you didn't answer to my question. How dare you use like a right angle math when when it's on globe? You show him why. You show them the central, and I'm gonna make fun the central angel, right? Because there was like you were like in seven heaven. There was like angels everywhere, right? So like you show them the central angel, and like what the fuck? Like this was insane, guys. Like it was super. I like, to be honest, I was like, because Peter down here, like Peter Stopa, he often like goes to their streams. And like Peter definitely doesn't have a like math and geometry skill as you guys. So like they can, and like it's always like 10, 15 on them, like 10, 15 on just Peter. And I always telling to Peter, just don't go there. Just imagine, I don't know, like how was the Glober that made his own Discord server that we start saying it's totally gay?
Or
yeah, or the small one, or yeah, Omnivore, yeah, exactly. So imagine, guys, that you will be coming like every week to Omnivore server, like talking with 15 Globers. Like, why would you do that? Like with 15 anti-flat earthers, right? And Peter is doing that, and like Peter, because like it's 15 of them on Peter, like it's like every time speak someone else over Peter. So like from whole picture, it looks like they have some arguments. It looks like they can say something. But now when it was like 1-on-1 or 2 versus 2, and you actually force them show what is wrong, what is right, they don't have nothing. They weren't able to show you what is wrong. Like they have nothing. And most pathetic was because they don't have even the English skill. So when there was like they get to the like end of their argumentation, they will start like repeating, "You didn't answer my question. Now you are running from the question." That was like so fucking retarded when you have opened the spreadsheet and you are showing them everything. And he's like, "Why are you running from this question?" Like,
dude. Have you ever been incorrectly wrong or wrong, and like have you been right in the wrong way before? Like, hey, I know that you got the right answer, but you did it wrong. But I'm still right. What? I've never been incorrectly wrong before, or whatever, or correctly wrong. God, I can't even say it.
Yeah, it was insane. So guys, like, props to you that you hold it for so long. I know that you actually hold it for me. So I know that. Like, because I read the message from Alan. It was like, when I can leave, just say when I can leave.
when is this over? When is it long enough for us to have been here?
Yeah. It was like, it was after the moment where, like, to be honest, it was after the moment that you said, so, okay, your basic argumentation is that we have the same conclusion, but we get like with different math, so that's why we are wrong. Like, I think that was like the time to wrap it up, but they made it. But no, it was amazing that you hold it so long, because man, how did you handle the thing with the star height or with the angle like during the year? Because like we all know that like probably that change is just in the stellarium, and we everything see every year on the same place and nothing changed really. We know that just like probably they're like quote unquote math that they use like to claim that we are moving from the universe, I think. But like it doesn't change anything on the CELTIO, and it was so amazing. Well, how did you handle it, guys? Like just yeah, you are right, guys. Nice. And like it was so funny how Paul, oh, I got you now. You were wrong as you are wrong in
me let him have
everything.
it.
And that was like so funny because like, dude, you have issue to complete one sentence that is not written, because I don't know if you guys noticed, but like every time when they kind of speak fluently, or I don't want to say fluently, but like with this like pauses, that was when they read it from the paper. Like we are 100% sure that they read it from the paper, because when you start actually talking with them, that was the moment was that was over. So they actually had everything prepared, like written word by word in English. And if you actually like straight away from their script, they were fucked. Like that was so obvious.
I don't blame them too much for that. There is a language barrier. So if they did do such preparation, I actually respect that, because that would save time and they would be able to, break it down slower if they had to, or go back to something. But
They didn't address anything we said though
but
the whole
but
time.
yeah,
So that's
but
that's
yeah,
that.
but yeah, overall it was just like, nuh-uh. Like,
Imagine to be clear, we at first would have had a problem with representing the globe with a right angle triangle as well. That was our first inclination, which is why we didn't do anything of the sort. At first, we just did the flat Earth prediction with a triangle, and then we just subtracted the angular drop, literally using the central angle theorem. That was the that was the Bennett method. That was the original Cell-Theo method. It wasn't to use a triangle to approximate the globe. Where we got that was from the Globers. The Globers came in and were like, "Oh, you're doing it wrong. We need to approximate it with another triangle at a lower height." And we were like, "Okay, like whatever." And that was one of the methods that we started using. And the one that I was showing when I was showing the triangles in the beginning of the prez, that's from Ruhif. Ruhif made those diagrams. He was trying to show me something, so I grabbed it from him, and I'm like, "I'm just going to use these, bro. These are perfectly showing like exactly the difference." So the funny for them to turn around and be like, "You can't do that." It's like, yo, Globers need to get together.
I will translate. This is epic. And by the way, Alan, I didn't mean it like that. I think it's amazing that they prepared, but I mean it the way that they actually didn't prepare. The way that they prepared their thoughts. They actually like prepared like structuralized text that they hold to and don't stray away from it, even if their logic is flawed, and you show them the flaw. That's how I meant it. Okay, so I think it's good that they prepared, but they kept it like script, and they like, even if you show them the fault, and it was actually in your last speak, and that was very well said it, because you tell them like, when you show me the mistake, I said, yeah, you're right, guys, that's correct. You show me a mistake, and we can move on, and I like, it's fine, and I guess I learned something new, and that's amazing. But like, if you show them any mistake, they were not able to even to understand it, because like they don't even think about it. It's like just reading the script, and when somebody say out of the script, yeah, whatever, it's not in the script, right? So that's way how I meant it. I will translate 1 second. Jenom abyste teda chápali, tak kluci jsou z toho jako taky úplně jako hustý, že to byl prostě jako naprostý masakr, naprosto jako nepochopení jakoby všeho, nepochopení hlavně i toho pravýho úhlu prostě od té kulatý země. S tím oni samozřejmě souhlasili, s tím oni měli problém taky, a tu matematiku, kterou oni se teďka snažili celou dobu napadat, tak tu vytvořili Jesse a Ruhif. Tu vytvořili ty jedni z největších antiplochozemců, od kterých oni ještě stejně, aniž by to věděli, tak kopírujou některé svoje argumenty, které dneska používali. Takže prostě oni v momentu, kdy se snažili říkat, že to mají špatně, a snažili se říkat, že to nefunguje, tak ale říkají, že to nefunguje jakoby těm jedním z nejlepších antiplochozemců, který to dávali dohromady a který je sami opravili prostě, jakoby, ale naše, že takhle to mají dělat. Takže to je jakoby tohle, my máme od Globeru, a to je to, co jsem já přesně říkal, že oni jsou tak strašně jako mimo a tak strašně odpojení, a vlastně tím, že neumějí anglicky, co jsme si dneska prostě bohužel jako všichni ukázali, tak oni vlastně ani nemají ty informace jakoby pořádně z té zahraniční scény z první ruky. Takže oni musí mít ty všechny informace nějak zprostředkovaný nebo s nějakým parapřekladem prostě, ale oni tomu jako reálně prostě sami nerozumějí. Takže největší úplně joke všeho tohohle z toho je, že oni nám říkají, že my kopírujeme obsah ze zahraničí, ale nerozumíme tomu. No největší prča je, že oni ho nejsou schopni ten zahraniční obsah ani obstarat, a nejsou schopní tím pádem ani jakoby si srovnat svoji argumentaci, protože teďka jdou vlastně Globeři proti sobě sami, proti sobě samotným. A my jako ještě ve finále všichni víme, že ta matematika je správně, protože Jesse na tom vytvořil tu celou simulaci, kterou jako reálně prostě aplikoval a použil ji k tomu, aby ty výsledky získal. Takže ještě oni jako reálně prostě ještě tvrdí, že to jako nefunguje, přitom máme simulaci, kterou vytvořil antiplochozemec, kterou sám použil k tomu výsledku a k tomu výsledku došel, a oni pak ten výsledek sami ještě chtěli používat. By the way, one thing that was hilarious as well. When you showed them the Jesse simulation, like they knew the simulation, like they were just acting like like that they don't know, because they were actually using like Jesse argumentation and Jesse simulation, like I don't know, maybe months ago against.
Well, you know
us,
how
so.
I know that? Because they were showing clips of our stuff with like their credits over it as one of their virtual cams for like the 40 minutes where they couldn't figure out how to use cameras. So I actually saw all the clips that they've seen of us because they were reusing it with their credits scrolling in like the Star Wars text. So I did see all of that. I saw Jesse's face, Jesse's simulator, McToon's channel, all that shit. So I know they've seen it all.
Yeah, man, that's so funny.
Dude, seen it all but understood none of it, unfortunately.
Pretended to understand none of it. Yeah, dude. Oh my god.
Yeah, like guys, actually, like I knew that they don't understand it, but I needed someone like you to expose them. Like, because there's probably no one better than you guys to expose someone like in this way. Like, it was amazing. Like, you exposed them so perfectly. Like, imagine that like the bot shit that was on the start, that was made because they were like saying that you, Alan, interrupt guys, and I am interrupting everyone, that we always interrupt, and that's how we keep the flat earth live, that we always everyone interrupt. Like, that guy wasn't able to keep his shit together, like, at all. That's so hilarious, because we are waiting like 10 minutes to get his shit out. We are okay because we have a language barrier, whatever. I understand that, and I'm fine with that. I'm not laughing to his English because it's bad. I'm laughing to his English because he's laughing to my English. So that's my excuse, whatever. But we are definitely okay to wait like 5 minutes to get his shit out. But in second that he understand like one argument, or like he hears something that is not okay for me, he immediately start interrupting, and it's like so awful. It was insane, like insane.
Yeah. So like, just to say that part out loud, if you're comfortable in your position and you know that you have like an actual defensible thing, then you're more comfortable to let your opponent say a long list of things you disagree with. If you're uncomfortable with your position, then the second that your opponent makes your position seem untenable, you have a visceral need to interrupt, because obviously you fear everyone will see how untenable your position is. That's the basic premise behind, juvenile interrupting. Okay.
Yes, sir. Yes, sir. I will translate that 100%. I agree. A vlastně já jsem tam přesně říkal o tom přerušování, a že vlastně kdykoliv, že největší sranda byla, že oni tam chtěli mít toho bota, že jo, který bude prostě hlídat to přerušování, protože tvrdí, že prostě Alan jako přerušuje, že jo, a že hlavně já a tak dále, tak prostě, že budou mít bota na to přerušování, jak všichni furt mluvíme. Hele, jakoby nikomu nevadí, že Vacek prostě mluví jako Tarzan, jako, já jsem s tím v pohodě, na druhou stranu není to jeho prostě primární jazyk, ani se angličtinu nemluvil, pohoda. Takže nikomu nevadilo podle mě, že se prostě 5 minut se snažili vymáčnout. To, že jsme si z toho tady dělali všichni srandu, jo jasně, protože se nám taky smáli prostě celý rok, jak je rok dlouhý, že moje angličtina je nejhorší na světě, jak tomu vůbec nerozumíme, jak plochozemci si neumí nic přeložit a tak dále. Jo, jasně, tak teď se můžeme zasmát, že jo, protože jsme pochopili, že naše angličtina je prostě jako o hvězdný roky daleko proti té její, takže v pohodě. To je jako OK, no, tak prostě angličtinou to asi nebude. Ale tohle mi vůbec nevadí, ale mě vadí to, že oni si vytvoří bota kvůli přerušování, a pak kdykoliv prostě Alan jako začal něco říkat, nebo Shane, tak oni jim okamžitě začali skákat do řeči. Kdykoliv tam přišel první jakoby náznak dobrýho argumentu, cokoliv, tak hned začali je přerušovat. Kdykoliv jim dávali odpověď, tak je hned začali přerušovat jak malí děti. No a Shane na to reaguje, že to je samozřejmě, že to je v momentu, kdy máš jakoby, kdy si nejsi sám jistý ve své vlastní pozici a kdy prostě cítíš, že tvoje pozice je ohrožená, tak máš větší tendenci někoho přerušovat. Mezitím, pokud jsi si jistý ze své pozici a jsi si prostě plně vědomý jakoby té argumentace a všeho, tak nemáš potřebu prostě toho člověka tolik přerušovat, naopak ho necháš klidně díl mluvit a pak jsi schopen to velice snadno vyvrátit. No a tohle je jako přesně to, co jsme tady viděli, protože oni si sami prostě jako nebyli jistí ve vlastní pozici a v momentu, kdy byla ta jejich pozice ohrožena, tak hned začali útočit prostě, no. Takže to je... Yeah, man, like, this was amazing. Like, imagine that these guys were telling that you guys are like cheaters, liars, scammers, drifters. And then after the debate, guys, it was so amazing. Could you come over? Could you come over again? We would like to talk with you again. Like that's so disgusting. When I know that they are calling you shame, they are telling you the shame shit after like Ruhiv or whatever who came with this. Like they are using like these lines and they are telling that we are liars, I am liar, whatever. And then it was amazing debate. We want to talk with you again. Like what? Guys, get your shit together.
Dude, you didn't hear what I said? I was like, we'll come back, but you got to have Dominic be the translator so we can have this go smoother. But that was my contingent.
Wait, okay, that was actually wasn't on the stream. Oh my god, like that must made them so mad, man.
I said it nicely, and I was like, please don't get like offended by what I'm about to say. But and then I said that, and then I told him that the arguments were juvenile and shit.
Well, we actually didn't hear your finishing speech because the stream for Alan ended. We hear only the Alan part, so we need to like listen your part after, like later. But
yeah, Alan didn't think that my closing statement was important. I guess that's cool.
Dude, so I closed it off for both of us in spirit.
It was like, fuck this, I'm out, dude. I can't do this.
Dude, just caught lying. Just like I can't do like so like you can't even be like, oh my bad, I was wrong. We're looking at it, say, subtracting the thing, and he's like, where's your arcaning the globe? Like that's anyway. What's up, Brian? My boy, how you doing?
Hey, Alan, I've got a rock solid refutation for celestial theodolite.
Oh, what do you got, buddy?
So all your flat Earth calculations are wrong because you're using the globe model, and all your globe calculations are wrong because you're not using the globe model. And I don't feel I need to be any more specific than that.
Yeah.
To correct that congruity in my head, so deal with that.
Yeah, that's exactly what that was like. You summarized this debate very well. I will just translate it for folks, jenom abyste jenom chápali, tak jsme se museli teď takhle strašně ještě smějeme, tak v podstatě ještě Shane na konci v té svojí závěreční řeči, kterou teda Alan utnul, tak Shane tam řekl, že ať se jako neurazej, ale že prostě jako neměli žádný argumenty, že to bylo jako strašný takhle a že pokud jakoby se chtějí, aby se ještě někdy vrátili, tak že si musí pozvat jako překladatele mě, aby ta debata měla nějakou úroveň a odscípalo to, takže tohle jim tam Shane řekl na konci, když odcházel, takže to si ještě pak musíme poslechnout, protože tohle věřím, že se jim asi úplně nechutnalo. No a ještě pak teďka přišel Brian a říkal, že má skvělý vyvrácení na nebeský teodolit. Všechny moje výpočty, jakoby, a teďka ta ironie, jakoby, na který to oni ty argumentaci staví, jo? Že v podstatě my máme výpočty postavený na kulatý zemi a proto naše výpočty jsou špatně. Oni mají výpočty postavený na kulatý zemi a proto jejich výpočty jsou správně. Ale žádnou další specificitu vám k tomu říkat nebudu, ale tímhle jsem vyvrátil nebeský teodolit. Yeah, it's so hilarious. Like, imagine that these guys are actually like their Facebook has around 20k members. So there's like 20,000 people who are actually like looking through like whatever they write or post. And these guys were claiming like for a year that you are liars, cheaters, you don't understand it, you have everything wrong. And this is like everything that they show us after the year. So
Dude, they were just repeating it. Can you use a triangle on a sphere? We instantly were like, no. And they were like, I didn't hear you. Can you use a triangle on a sphere? And we were like, no. They were like, I don't know. Did you hear it? No, ask it again. Why are you running from answering whether to use it? It was like, what? Whoa, we said no 100 times. Here's why no. Here's how no. Why do you keep saying that? It's so confusing.
I can't pull over any further.
Yeah.
But yeah, GG's lads.
Yeah.
So if anyone has any meaningful refutations to the celestial theodolite, just send them in PDF form, I guess. That would be.
Well, it should be
easy.
Like, people make fun of that we've been doing it for like 24 weeks, and it's like, bro, so we do it because we keep hoping that one of you will refute it, and if one of you did, we wouldn't be doing it every freaking week with a wide open invitation and a hopeful expression or whatever.
Yeah, and that was like, wait, you are maybe like the details. I don't think even I shared them with Alan, but they're like funny thing about how they are like this opposition, what they are claiming, they were saying that they cannot actually get to these updates because like they thought that these updates for Celestial they are like here on Ethercos. And like for half year, they were claiming that they can't get actually, that they want, but they can't actually get to these updates because they're all banned here on Ethercos. So like maybe like 2 months ago, I actually like explicitly told them that these updates are happening like on Earth Awakening and everybody can go there, like everybody. There's nothing to do with Ethercos. We made it there specifically because there's like people that are banned on Ethercos and we don't want them there, but we can actually like meet them on neutral ground and we can talk there and they don't have to shit on like actually in our home, like whatever I feel like we can say it's our home. Right?
they don't have to shit where we eat.
Exactly,
Yeah.
bro. That's it.
Yeah. So, but this was funny because now I think that they were actually scared because they knew that this would happen. Like in future, this debate will happen, and they were trying to postpone this debate with this lie that they can't actually get here and that they can't actually get to these updates. So that's why we made actually this debate because that actually was why this debate was made.
We went to them. Nice.
Yeah.
Dude, all our
we actually made
updates
this
are
debate
public.
because they were lying that they can get here to these updates.
Yeah, all our Ethercos stuff weekly is posted on the neutral platform. There's only one person that's banned from communication on there, so literally anyone else who hasn't egregiously lied repeatedly directly to my face, is welcome to take a crack at it.
Yeah, I will translate that. Jinak pro všechny antipolchozemce, kteří tady ještě pravděpodobně třeba někteří jsou na YouTube, tak samozřejmě Alan a Shane tak vás vřele vítají, pokud byste kdokoliv z vás měli jakoukoliv jako reálnou argumentaci k nebeskému teodolitu, kromě toho, že nemůžete používat pravouhlej trojúhelník na kulatý sféře, tak kdybyste měli prostě nějaký jako reálný argument. You actually know what I said now, I know you know. Takže kdybyste někdo měli jako nějaký reálný argument a chtěli byste ho přinést, tak přinést to v jakýkoliv formě PDF-ka, kluci rádi se na to podívají. Případně jde domluvit samozřejmě i nějaká jako důstojná debata, ale už ne nic takového. Tohle byl prostě naprostá jako komedie a šaškárna, že jo, to se asi všichni shodneme, takže cokoliv prostě, co bude mít nějakou úroveň, tak určitě. Yeah, I was saying the thing about the right angle and sphere. It's so hilarious. Like it's so funny, man. Like they actually didn't have any argument, like any refutation, and when they get to the that starts changing angle yearly, they were like so happy. You can actually see the happy.
Yeah, I saw how gratifying it was.
Yeah.
So just to be clear, their whole contention was based on another Glober who told us that we were doing it wrong. So what they saw was another Glober strawmanning the globe, and they were like, "No, you're doing it wrong." And all we did was take both of them and refute them directly. We was like, "Here's your interpretation of what you think the globe should be. Here's your interpretation of what you think the globe should be." But I had no idea they were competing with each other, though. Like those people directly were attacking Ruif. So.
Yeah, that was so funny when they said that like you strawman the globe, but they didn't realize that you have like 7 or 8 different like specification of globe, like from like all different globers, like from everywhere. They are so behind from like all these updates. They just don't imagine that. I know that. Like we are a small Czech nation, right? We are a small country, and maybe they think that we are like center of universe, and we actually are in the center of universe, and it's spinning everything around us. But you have to have some like middle ground, right? You have to, like, it's insane.
Dude, like, how come the whole world doesn't already know how genius this is? And I'm like, I mean, if that's your position,
dude. Oh yeah, I was gonna comment on that. Like, why doesn't everyone, why isn't this the next greatest thing? It's like. Well, some people have a real hard time understanding subtracting central angle theorem and doing the exact same thing you're doing to arrive at the same conclusion.
So funny. Well, so central angle theorem and the 2 triangles, we started using the 2 triangles because they both provide the exact same prediction. That's why we thought that was negligible. Well, like if one glober wants to use a smaller triangle to approximate a flat Earth prediction that is just, flat Earth minus globe, well, that's fine. That's valid. Did you get 217? Fine. We'll add it to the board or whatever. You know, that's how we got there.
Yeah, I will translate that. A jenom abyste ještě byli teďka v obraze, tak ještě hrozně taky pobavilo to, když tam, myslím, že to byl Polame, začal říkat něco v tom smyslu, jako že no a když máte takhle něco revolučního, tak proč už to jako neví o tom celý svět a proč už jste nezměnili celý svět, no a na tomu jako Alan prostě jak už byl zoufalý, tak ale nechal to pro sebe, tak mu chtěl říct něco v tom smyslu, že protože spoustu lidí má prostě jako problém pochopit, že můžeš prostě odečíst ten úhel od toho centrálního úhlu a že můžeš udělat prostě tu matematickou funkci, kterou oni udělali a že spoustu lidí to má prostě jako velký problém to pochopit, i když jim to jako někdo takhle furt ukazuje, no, ale že jste to jako pak nechali pro sebe, ale že to bylo jako extrémně vtipný, no. Což už jsou takový ty klasický, ale jejich jako stromeny prostě, který oni používají. By the way, this is actually when I knew that you get them to their like a weak spot, that you hit them in their weak spot, because when they start acting like this childishly, like they were acting, they were doing the same thing in debate with me. So yeah, that's the moment when I knew that they are finished. Like when they start acting like little kids, like that's exactly what they actually are. Yeah. Exactly.
I said he was acting juvenile, and he was like, "Excuse me, sir," and I was like, "Whoa, like what the fuck."
When there was like the excuse me, we were like laughing so hard here. It was so funny. Like imagine you said them like very well like said and very well thought like argumentation, and they're like, excuse me, sir.
It was so morally affronted that I was like, stop acting like a kid. Right? That was pretty much what I said. I was like, why are you gonna be like? There's no need for that juvenile bullshit of dancing around pretending. They were like, "What? I never."
Exactly.
Like, I think she protests too much or whatever.
Yeah, by the way, I translated your challenge, so I think there are definitely like globers and anti-flat earthers that are listening us. So I said if there's like anyone who have some real argumentation, bring it up, guys, bring it up. Like that's the whole reason why these updates are here. Like it's so funny. Like if there was any real refutation, we wouldn't be actually here. Like we wouldn't be like, we would be, oh, okay, wow, we missed that. Like that would be all. Like it would be bomber, but
Alan put it all on the line already. He was like, for me personally, if the Southie approved a globe, I'd be a glober. After TFP, he was like, "This,
I agree.
This is it."
If there's a physical elevation change in the stars, like they assert, the only thing that could produce that would be because of the ground is doing it. So the fact that that doesn't happen, it's like, how to explain it?
Glaring
like,
problem.
Don't care. Why is this north and south different? Doesn't matter. What matters is that they don't change in physical elevation. That's always apparent. And that's the globe model is built on that being a physical real change.
Yeah, and like there, I will translate this one, and I will also comment on their like Haversign bullshit. That was also super funny, and that show how they don't understand anything about our position. Jinak ještě Alan teďka říkal, že vlastně třeba on, tak to má postavený opravdu tak, že kdyby hvězdy, že ho nezajímají všechny jako věci okolo, ale hvězdy nemění svoji skutečnou výšku. Ty hvězdy zůstávají furt ve stejné výšce. Všechna ta změna, kterou tam my vidíme, je optická. Veškerá ta změna v té výšce k těm hvězdám, tak je optická. Kdyby se prokázalo, že ta výška k těm hvězdám je fyzická změna, tak jediná možnost, která by způsobovala tu fyzickou změnu těch výšky těch hvězd, tak je, že by ten povrch té země byl zakřivený. To je jediná možnost, kdyby prostě se měnila ta fyzická elevace těch hvězd. Ta se nemění, ta zůstává stejná. Máme to prokázané i na tom zatmění, na kterém bylo prostě nějakých 6,5 tisíce datových bodů. Takže nemění se fyzická skutečná elevace k těm hvězdám od té země. A pokud se nemění ta skutečná fyzická elevace od té země k těm hvězdám, tak prostě země nemůže být země koule. Protože by se měnila ta fyzická elevace těch hvězd. Yeah, like I think they show it like perfectly when they're like, oh, you are using a Haversine formula, that's a globe formula, that's like on counting distance on curved surface. You can't use that. Like they know about, like, they saw every single presentation. They are doing quote unquote debunks on our presentations. So like, what?
Yeah, but the whole argument about the Haversine is that, okay, but you know, the difference if we were to, you're arguing about 13 centimeters. The Haversine argument is that, no, that line would be longer, different on a globe. And it's like, true, it would be different. You know by how much it would be different? The answer is usually no, because the argument ends there, right? They're just trying to invalidate it. So if you want, it's a 13 centimeter difference. The length of that line is 13 centimeters difference between a sphere and a straight plane. That's why we can approximate it with a triangle to get the same answer. That's why it doesn't matter. The distance between, like, the argument with Haversine is that it would be a different distance. So yeah, so again, different by 13 centimeters. Just saying.
And then he said he knew that. If I remember correctly, he was like, I know.
Yeah, he was like, I know what arc and
centimeters.
chord are. I was like, oh, great. Well, then he was like, you're right. We were like, it's 13 centimeters. He was like, you're right. And it's like, okay, well, how do you know that and repeat that horseshit argument you just said?
Yeah, it's like, and my boy just gave us a 224 meter plus or minus buffer. So like, I'm pretty sure if I'm not like an expert in math or any shit like that, but I'm almost positive that 224 is a larger number than 14 centimeters.
But just a little bit. Like, it's like you can hide globe there if you want. Like if you.
Yeah, dude, the globe's hiding in that difference. Yeah, dude. Well, I'm gonna head out of here. Take a little break.
Yeah,
it's a good show.
Yeah, sure, guys.
Shout out to
go walk the dog.
Shout out to all the Czech lads out there, and yeah, I mean the importance of like knowing the fundamentals of the argument from the ground up is the only way to prevent the gaslighting and just outright lying. Because like they're just gonna lie about everything. The dude he's literally been telling people we're using a different formula that's in our spreadsheet that anyone at any time can go and look and verify, and they're just like, now we're just gonna say a different thing. Like that's so absurd. Like I can't imagine living a life like that where you just know nothing but want to talk about it all the time. It's crazy. All right,
and then just imagine like you start your intro speech that we are in year 2025 and we are talking about flat Earth when they are like living by like with everything around flat Earth. Like these guys are like what we call anti-flat earthers, right? So they're actually like living like with flat Earth even like more than like some of us actually do, right? So it's like for them like making even like fun that they are like talking about that topic when they don't anything about the topic and they actually like are in the topic like every single minute of their personal life. It's super funny. Yeah, man, like props to you guys. You did very well and you hold up your emotions very well. It was amazing. Like actually like for me watching you guys debate is amazing because I always like learn more how to debate and more how to react. So it was very well. Thank you guys.
Thank you. See you guys on tomorrow for Celestial Theodolite Eclipse Edition. We're going to be breaking down for the lads and ladettes the stuff that we went over, that I tried to go over with Jaren, and I suspect that there will be considerable amounts of less interruptions when we do the Globebusters episode. So maybe people will get a coherent view of what's going on with the Eclipse thing, because what Brian did with the eclipses was just icing on the cake.
It's amazing. Yeah.
There's no coming back from that.
I will be definitely listening.
Yeah,
100%. I will be definitely listening, guys. Thank you very much.
Thank you, guys. Thank you, everyone who calls Ether calls home.
Yeah, and then always,
home, guys.
Celestial Theodolite update number 26 will be on Earth Awakenings on Monday, 8 p.m. Eastern.
As always.
As it has been for the past 26 weeks or 25 weeks, whatever. Anyway.
Yeah.